We will be watching the Artemis 1 press conference here in a moment. Let me get a video up for you guys. How about... Let's go. All right. Let me change up the title to... I'm going to take a quick break, and we'll go from there. It's getting really hot in here today. It's 80 degrees in here, 26. I gotta get that insulation in here. All right. I will be back in a second. Oh, no, not that. Not that. Be right back. Yeah, there we go. All right. I'll be back in a second. Enjoy.
When ancient man looked to the heavens for guidance from the gods, he noticed star patterns and began to document their movement across the heavens. The ancients believed that the earth was flat, but around 350 BC, Aristotle proved that the earth was round. Later, about 150 AD, Ptolemy presented the geocentric theory, the belief that the earth is stationary at the center of the universe, with the sun, moon, stars, and planets revolving around it in complex orbits. In the 1500s, Nicholas Copernicus of Poland presented the heliocentric theory, the belief that the Earth revolves around the sun as it rotates on its axis. This aspect of astronomy evolved into an intricate study of planetary motion known as orbital mechanics. Today, orbital mechanics is applied to space flight and satellites that orbit the Earth or travel beyond our solar system. In the early 1600s, Johann Kepler, a German mathematician, using the data on planetary observations collected by the Danish scientist Tycho Brahe, developed 3 laws of planetary motion. Kepler's first law states,
all planets move in elliptical orbits with the Sun at one focus and the other focus empty.
applied to Earth satellites, the center of the Earth becomes one focus, with the other focus empty. For circular orbits, the 2 foci coincide. Kepler's second law, the law of areas, states,
the line joining the planet to the Sun sweeps over equal areas in equal time intervals.
when a satellite orbits, the line joining it to the Earth sweeps over equal areas in equal periods of time. If areas 1, 2, and 3 are equal, times 1, 2, and 3 are also equal. Therefore, the speed of the satellite changes depending on its distance from the center of the Earth. Speed is greatest at the point in the orbit closest to the Earth, called perigee, and is slowest at the point farthest from the Earth, called apogee. It is important to note that the orbit followed by a satellite is not dependent on its mass. A large, heavy satellite could be in the same orbit with a small, light one, each sweeping out equal areas in equal periods of time. Kepler's third law, the law of periods, relates the time required for a planet to make one complete trip around the Sun to its mean distance from the Sun.
For any planet, the square of its period of revolution is directly proportional to the cube of its mean distance from the Sun.
Applied to Earth satellites, Kepler's third law explains that the farther a satellite is from the Earth, the longer it will take to complete an orbit, the greater the distance it will travel to complete an orbit, and the slower its average speed will be. Isaac Newton, the father of classical mechanics, laid the groundwork for orbital mechanics. He combined the work of Kepler and others to formulate the law of universal gravitation and the three Newtonian laws of motion. While Kepler's laws provided a conceptual model of orbital motion, Newton's laws provided the foundation for the mathematical description of orbits. They explain why a satellite stays in orbit. Newton's law of universal gravitation.
Any two objects in the universe, such as the Earth and the Moon, attract each other with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between them.
Stated more simply, the more massive the objects are, or the closer they are, the greater the gravitational pull between them. Newton's first law of motion.
A body in motion will keep moving at the same speed and in the same direction unless acted upon by an external force.
A satellite moves in a curved path around the Earth because the Earth's gravitational pull acts as an external force on it. Newton's second law of motion.
If the sum of the forces acting on an object is not zero, the object will have an acceleration proportional to the magnitude and in the direction of the net force.
Newton's second law states that force equals mass times acceleration. It is this mathematical equation and the equation for universal gravitation that forms the basis for calculating orbits. Newton's third law of motion explains how a satellite gets into orbit.
For every action, there is an equal and opposite reaction.
If you blow up a balloon and let it go, the balloon is pushed forward by the action of the air rushing out of it. A rocket's exhaust gases are like the air rushing out of the balloon. The following illustrates how a satellite stays in orbit. If a man stands on a mountain and fires a projectile horizontally, gravity will cause the path of the projectile to curve downward and it will strike the Earth. However, if the man fires the projectile fast enough at a specific speed, the curvature of its path due to gravity will match the curvature of the Earth under it. The projectile will then fall around the Earth, becoming an Earth-orbiting satellite. A projectile fired even faster will have a flight path away from the Earth, but gravity will act to slow the projectile down, change its flight path, and pull it back toward Earth. If the projectile's velocity increased enough, a velocity sufficient to escape the Earth's gravitational pull will be reached. This velocity is known as the escape velocity. It is equal to about 7 miles per second at the Earth's surface. The preceding description did not consider atmospheric drag and the Earth's rotation, both of which will affect the trajectory of the projectile. It illustrated the principles governing a satellite's orbit. There are 6 numbers called the orbital elements, which specify the size, shape, and orientation of an orbit in space, as well as the location of the spacecraft in the orbit. Based on an orbit which is an ellipse, the 6 orbital elements are length of the semi-major axis, eccentricity, inclination, right ascension of the ascending node, argument of perigee, time of perigee passage. The major axis of an elliptical orbit is the line joining the perigee and apogee. This line is also referred to as the line of apsides. The first orbital element is the semi-major axis. It is simply 1/2 the major axis. Circular orbits have no apogee or perigee. Therefore, the semi-major axis is simply 1/2 the diameter of the orbit. The semi-major axis is used to define the size of the orbit. From this, the orbital period, or time that it takes for the satellite to complete one orbit, can be calculated. The shape of an orbit is defined by the second orbital element called eccentricity. For all ellipses, the value of eccentricity lies between 0 and 1. The larger the value, the more elliptical the orbit. A spacecraft in Earth orbit with an eccentricity equal to or greater than 1 will escape the Earth's gravitational field. When orienting an orbit in space, a 3-dimensional coordinate system must be defined. The coordinate system commonly used is the geocentric equatorial coordinate system, which has its origin at the Earth's center. This coordinate system is a non-rotating reference system in which a satellite's orbital plane tends to remain fixed relative to the stars while the Earth turns beneath it. The XY plane is the Earth's equatorial plane. The positive x-axis points to the vernal equinox. This is the point where the sun appears to cross the Earth's equator on its way north on the first day of spring each year. The z-axis is along the Earth's spin axis toward the North Pole. Nodes are points in a satellite's orbit which intersect the Earth's equatorial plane. The ascending node is the point at which the spacecraft crosses the equator going from south to north. The descending node is where the spacecraft crosses the equator going from north to south. The line joining the 2 nodes is called the line of nodes. The orientation of an orbit is determined by 3 orbital element angles. The right ascension of the ascending node is the angle between the x-axis and the ascending node. It is always measured eastward from the direction away from the vernal equinox in the Earth's equatorial plane. The argument of perigee is the angle between the ascending node and the point of perigee. It is measured in the orbital plane in the direction of spacecraft motion. Inclination is the angle between the equatorial plane and the orbital plane. A satellite which has an eastward velocity component at the ascending node has an orbital inclination lying between 0 and 90 degrees. Such an orbit is called a prograde orbit. A satellite which moves due north at the ascending node is in a polar orbit. Polar orbits have an orbital inclination of exactly 90 degrees. A satellite with a westward velocity component at the ascending node is in a retrograde orbit and has an orbital inclination between 90 and 180 degrees. The 5 orbital elements explained thus far describe the size, shape, and orientation of the orbit in space. The final element is a time value used to locate the satellite in its orbit. A satellite moves in a very predictable manner. It stays on schedule. Thus, if the time at which a satellite passes a particular point is known, the time when it will pass any other point can be determined. The particular point chosen is perigee, and the time of perigee passage is the last of the 6 orbital elements. The 6 orbital elements depict a spacecraft's orbit in non-rotating coordinates. To visualize an orbit relative to the rotating Earth, a projection traces the spacecraft's position on the Earth's surface. The projected path is called the ground track. As a satellite orbits the Earth, the ground track shifts westward. There are 2 causes for this. First, the primary contributor is the Earth's rotation toward the east under the orbital plane. Second, because the Earth is not a uniform sphere and bulges at the equator, its gravity is greatest at the equator. This causes the orbital plane to rotate slowly around the Earth's polar axis in a motion called precession. Precession is toward the west for prograde orbits and toward the east for retrograde orbits. For low Earth orbits, such as those of the Space Shuttle at 150 miles altitude, the westward shift of the ground track due to the Earth's rotation is about 22.5 degrees, while the shift due to precession is only about a half degree. The inclination of a satellite orbit determines the north and south latitude limits of its ground track. The minimum orbital inclination is equal to the latitude of the launch site and is achieved by launching due east. For example, if a satellite is launched due east out of the Kennedy Space Center, which is located at 28.5 degrees north latitude, its orbital inclination will be 28.5 degrees, and the limits of its ground track will vary between 28.5 degrees north latitude and 28.5 degrees south latitude. If launch azimuth or direction of flight at launch, measured eastward from due north, is increased from due east, the orbital inclination angle increases as well as the maximum latitude of the north-south ground track. Therefore, the latitude limits of the ground track equal the new launch inclination. Similarly, if launch azimuth is decreased from due east, orbital inclination once again increases as well as the latitude limits of the ground track. The maximum practical inclination from a Kennedy Space Center launch is 57 degrees. This limit is imposed for safety considerations in order to keep the spacecraft and its booster system from flying over land masses during the ascent phase. To obtain an orbit with an inclination greater than 57 degrees, the spacecraft is launched from Vandenberg Air Force Base in California. Vandenberg offers the opportunity for southerly launches with orbit inclinations between approximately 70 degrees prograde through 138 degrees retrograde. A significant advantage of launching from Vandenberg is the capability to economically achieve polar orbits with ground tracks covering all latitudes, from the North Pole to the South Pole. The Earth is constantly turning, and all points on its surface have an eastward velocity, with the greatest velocity occurring at the equator. The farther the launch site is from the equator, or as launch azimuth is increased or decreased from due east, less of the Earth's rotational velocity will be imparted to the launch vehicle. This requires more fuel to get into orbit, or payload weight will have to be decreased. Launches due east from a position on or near the equator, such as the Kourou launch site in French Guiana, used by the European Space Agency, acquire the advantage of a free velocity gain of about 1,500 feet per second. This compares to the approximate 1,300 feet per second gain available at the further north latitude of the Kennedy Space Center. Launching from an equatorial site offers a significant advantage in payload weight capability and minimizes the amount of fuel needed to achieve an equatorial orbit. Since many satellites operate in equatorial orbits, these are important considerations. Spacecraft are launched within a specified time interval called the launch window. Some of the factors affecting the launch window are launch and orbit lighting conditions, sun angles, payload orbit requirements, rendezvous phasing if a rendezvous is planned, tracking and communication requirements, and collision avoidance with other orbiting objects, to name a few. One of the factors defining the launch window for the Space Shuttle is launch lighting conditions, which can be illustrated by plotting time versus day of year. On this plot, we see daylight and darkness at the launch site. The longer daylight hours occur in the middle of the year, summertime. If daylight conditions are required for a convenient emergency landing site for the Space Shuttle, the launch window would now look like this. During the winter months, the available launch window for lighting conditions alone can be as little as 3 hours per day. When combined with the many other launch factors, the launch window becomes even more constrained. The choice of a particular launch vehicle for a mission depends upon the weight and size of the payload and the desired orbit. Expendable rockets used to place spacecraft in orbit usually consist of several stages that may incorporate both solid and liquid propellants for propulsion. When the fuel in each stage is depleted, the spent stage is jettisoned. Staging offers the advantage of discarding weight when it is no longer needed. The Space Shuttle is a two-stage system. At liftoff, the 2 solid rocket boosters and 3 Space Shuttle main engines are all producing thrust. After approximately 2 minutes of flight, at an altitude of 25 miles, the fuel in the solid rocket boosters is depleted and they are jettisoned. The 3 main engines, fueled by liquid oxygen and liquid hydrogen carried in the external tank, continue to burn for several minutes until the shuttle reaches its cutoff velocity. At this time, the main engines are shut down and the external tank is jettisoned. 2 additional burns using the orbiter's maneuvering system, referred to as OMS, are required to place the orbiter in its final orbit. The OMS 1 burn occurs about 2 minutes after main engine shutdown and establishes the orbital apogee point. The OMS 2 burn takes place approximately 30 minutes later and circularizes the orbit. Once satellites are launched and put into orbit, it is often necessary to change the orbit with an on-orbit burn. The common term used in describing on-orbit burns or engine firings is delta V. Delta V is the incremental change in spacecraft velocity measured in feet per second resulting from the burn. The amount of fuel used during a burn depends on the desired delta V change and the mass of the spacecraft. Because the amount of fuel carried is limited, fuel consumption is one of the primary considerations in spacecraft mission planning and is critical to orbit lifetime. On orbit, a spacecraft can thrust in any direction. Burns along the flight path, forward and backward, are the most common. A unique feature of any orbital burn is that if no other burns occur, the spacecraft will later always pass again through the point of burn. Forward burns increase the spacecraft's velocity and are known as posigrade burns. With posigrade burns, the flight path of the vehicle will be raised at all points except the burn point. Burns opposite the direction of flight, which slow the spacecraft down, are called retrograde burns. For retrograde burns, the orbit will be lowered at all points except the burn point. The greater the delta V, the greater the difference between the pre-burn and post-burn orbits. Burns can be combined into maneuver sequences to change orbit size, shape, or orientation. One of the most common maneuver sequences is made up of two burns and is used to accomplish an orbit transfer between two circular orbits in the same orbital plane. The most energy-efficient transfer between two orbits of this type is the Hohmann transfer. The Hohmann transfer is actually 1/2 of an elliptical orbit with its perigee in one of the orbits and its apogee in the other. The burns occur at the perigee and apogee of the transfer orbit. The use of the Hohmann transfer minimizes the delta V required, thus having the advantage of using minimum fuel. The disadvantage of the Hohmann transfer is that it takes longer than most other transfers. The type of the transfer sequence depends on the mission and the amount of fuel available. For example, a space rescue where time is critical might use a fast transfer, while a routine satellite deployment where fuel saved for later use is important would most likely use a Hohmann transfer. The burns discussed so far have all been maneuvers in the original orbital plane and do not affect orbit inclination or node position. There are situations which require an orbital plane change, such as setting up a rendezvous or placing a satellite in an equatorial orbit. To change the inclination, the thrust vector must be directed at an angle to the orbital plane. A thrust with a component that is perpendicular to the orbital plane at either the ascending or descending node will rotate the orbital plane about the line of nodes. A northerly out-of-plane thrust at the ascending node will increase the inclination of a prograde orbit, while a southerly thrust will decrease it. Out-of-plane thrusts require considerable amounts of fuel and are performed only when absolutely required. The Space Shuttle, for example, using all of its onboard propellant, is capable of an on-orbit plane change of less than 3 degrees. Satellite orbital planes and altitudes are determined by their design mission, which very often includes a field of view requirement for optical or communications purposes. The field of view of a satellite is defined as the area of the Earth's surface that is in view from the satellite at any given time. Satellites in high orbits have greater fields of view than those in lower orbits. For example, a satellite at an altitude of 800 nautical miles has a circular field of view with a diameter of about 4,100 nautical miles. A satellite at 200 nautical miles has a circular field of view with a diameter of about 2,000 nautical miles. Low-orbit satellites are often used for photography and other types of Earth observation. A satellite placed in a low-inclination circular orbit at an altitude of about 19,300 nautical miles will have an angular velocity exactly equal to that of the Earth's. The satellite would seem to remain stationary in longitude as viewed from the ground. Such orbits are called geosynchronous and are used to provide a continuous communications capability among any system of ground stations within their field of view. The geosynchronous orbit field of view is constant and is limited to a latitude zone of about 70 degrees north and south of the equator. Effective satellite communications from geosynchronous orbit is not possible at either pole. However, because of their altitude, their field of view covers nearly half the globe. A special type of geosynchronous orbit with an inclination of 0 degrees is called a geostationary orbit. It appears to hover over a fixed point on the Earth's surface at the equator. Most U.S. communication satellites are in geosynchronous orbits, providing near worldwide communications coverage. For effective communications at high latitudes, the Molniya orbit is used. Molniya is the Russian word for lightning and is an orbit used extensively by the Soviet Union for its communication satellites. The Molniya orbit is highly eccentric with an apogee that is near the geosynchronous altitude and an inclination of about 63 degrees. The satellite slows down at apogee in the northern hemisphere and whips through perigee in the southern hemisphere. This provides communications in the northern hemisphere for up to 75% of its orbital period. Several satellites properly spaced in Molniya orbits can provide constant communications at the northern latitudes. Navigation satellites, such as the U.S. Navy's Transit System and the Joint Service Navstar GPS Global Positioning System, use lower orbits so that a user can receive signals from more than one satellite at any time. Another frequently used orbit is known as a sun-synchronous orbit. These take advantage of the precession of the orbital plane caused by the Earth not being a perfect sphere. All sun-synchronous orbits are highly inclined retrograde orbits which precess eastward around the Earth's polar axis at the rate of 1 revolution per year. Since the Earth-Sun line also revolves eastward at the rate of 1 revolution per year, the orbital plane will maintain a constant orientation relative to the Earth-Sun line. If the satellite's period is then synchronized with the rotation of the Earth, it will pass over the same point on the Earth's surface at the same local time at a regular interval. A sun-synchronous satellite ensures that a constant sun angle and uniform lighting exist for the same field of view from pass to pass. Satellites such as those in the Defense Meteorological Satellite Program and Landsat are sun-synchronous, imaging the entire Earth on a regular schedule. The gravitational attraction of the Earth on a spacecraft causes it to move in its orbit around the Earth. There are other, much smaller forces which will cause a spacecraft to deviate from its desired orbit. These forces cause what are known as orbital perturbations. Orbital precession, which is used to obtain sun-synchronous orbits, results from the perturbing effects of the Earth's non-spherical shape. Other perturbing forces are the gravitational pull of the Sun, the Moon, and planets, and solar winds, which are charged streams of protons and electrons that heat the Earth's atmosphere and increase atmospheric drag. In most cases, perturbing forces can be compensated for in the spacecraft and orbit design and present no major problems. If the forces disturb the orbit too much, thrusters can be fired to re-establish its desired orbital orientation or altitude. This is particularly true for spacecraft orbiting at very low altitudes, where the effects of atmospheric drag are greater and, if not compensated for, will eventually cause the spacecraft to deorbit. A spacecraft's operational lifetime is frequently limited only by the amount of fuel available to maintain its desired orbit. When its useful life is complete, a satellite is left in orbit or is deorbited, burning up when re-entering the Earth's atmosphere. When the space shuttle completes its orbital mission, it executes a precise retrograde burn to initiate its controlled return to Earth. This burn occurs nearly halfway around the Earth from the landing site. The new orbit established by the retrograde burn causes the orbiter to enter the Earth's atmosphere about 4,000 miles from the landing site. During the period the orbiter descends from its orbital altitude to atmospheric re-entry, its attitude is maintained by the use of reaction control jets located in the nose and tail of the orbiter. Once the orbiter enters the Earth's atmosphere, its wing and tail aerosurfaces begin to become effective and gradually replace the jets for attitude control. As the orbiter nears the landing field, it maneuvers to a long, straight-in approach at an angle of 17 to 19 degrees. Nearing the runway, it executes a flare maneuver to reduce its sink rate and glides to a touchdown at approximately 230 miles per hour. As the orbiter rolls to a stop, our journey into the world of orbital mechanics comes to an end for now. This is only the basics of orbital mechanics, an intricate study of planetary and satellite motion. The next time you see a launch, you will see it from a different, somewhat knowledgeable perspective. You will understand the fundamentals of spaceflight.
Sir, can I talk to you for a minute, please, sir? I'm in trouble with the microphone, sir. I've lost the bleeps, the sweeps, and the creeps. The sweeps and the creeps. It's not all he's lost. Here on Vox, we could hear everything you say. What exactly did you have for food? Yes? Now I need to go watch it with you're welcome. Alright. So big okay, we got big news. Eric is pregnant. No, please stay muted, Kappa. Plus type better, Kappa. I want you to comb the desert. Comb the desert! Found anything yet? Not a thing, sir! I'll give you the raspberry. Raspberry? Organonant? We ain't found nothing! Sorry, sir. Doing my best. Who made that man a governor? I did, sir. He's my cousin. Who is that? He's a moron, sir. I know that. What's his name? That is his name, sir. Now we're just gonna do... We're just gonna do Spaceballs quotes. Till then. Wow, toxic strummer. Keep firing! Keep firing, chat! How many chatters we got in this stream anyhow? Yo! Can't believe it, I'm surrounded by chatters. Keep firing, chatters! What's the matter, Colonel Sanders? Chicken? That's the... Dude, Grayville, that's the one that gets me every time. Promotion! Promotion for ludicrous speed! That in Wayne's World when Stacy gets Wayne a gun rack. What is it? It's a gun rack! A gun rack? A gun rack! have the ring. And I see your Schwartz is as big as mine. Let's see how well you handle it. Never put that mask down in front of me. How do I know you're not making faces at me under that thing? May the Schwartz be with you. All right. Okay. Anyway, that was a good start to space news. I actually have to be somewhat professional here for a moment, so please give me a second. All right. We got to dial in. Okay, so welcome to Space News. We have a NASA press conference in about 10 minutes, give or take. Knowing NASA, it's probably about 15. I should make that your YouTube front page video. Okay. Okay. All right, focus, speed. I am a little brekkie could be good for me. No. Focus, speed. All right, anyway. So we have a big NASA presser coming up. It is an update for Artemis 1 and what they kind of where to go from here. So if you didn't see the Artemis 1 first launch attempt on Monday morning, they did scrub. They had some trouble with the bleed lines in the main propulsion system. Particularly getting engine 2 or engine 3 to be able to, he said 2 to be able to bleed. So what does that mean? So we're looking at, if you're looking at SLS, you have the 4 engines down at the bottom. They're inside of kind of a aft section that's behind the hydrogen tank. That's the engine section for SLS. That is called the MPS, main propulsion system. That's the name for it. Now, in reality, they wanted to launch at a more reasonable hour. Engine 3, aka Engine 2058, which has flown on 6 shuttle missions, which is cool. So they had problems getting the engine to bleed down. So what's bleed down? Basically, getting all the gaseous hydrogen out of the system. They want to get all the gas out of the plumbing and fill it up with fuel. The reason why you want to do that is because if you start the engine and there's gas in the lines, yeah, it could cause problems to say the least, like explosions. You want the fuel lines going to the engine basically to be filled with fuel and not gas. So they did have a problem with it. They weren't able to get engine 3 down to the correct temperatures. They weren't able to thermally condition the engine correctly. Now, everybody in their infinite wisdom's now like, oh, engine 3 memes. But I have a feeling that it's core stage related. Yeah, I have a feeling it's core stage related. In fact, I think it's MPS related, the main propulsion system, so the engine section of SLS. I think it's related to that. I think there is a problem with the valves that are not engine related that will not require an engine swap. Now, why do I think that? Well, NASA's been using these engines for a pretty long time. I think they understand how they work, considering they used an engine design that's basically this for about 30 years. The only real new thing here, and keep in mind, the engines have been refitted. They've been updated with new avionics and stuff, but at the end of the day, they're still shuttle engines. So I'm pretty damn confident that this is core stage related. The question is, did they see this behavior at any point in the past? So if they didn't, that means they've encountered new behavior, which is probably not something that you necessarily want on a first launch attempt. However, at the same time, hey, Dev Random, 7-month resub, thank you. However, at the same time, it is a new launch vehicle. You're going to encounter new behavior nonetheless, because it's a new launch vehicle. They've never put that thing on the pad and then with the intention of sending it before. So they could have encountered new behavior. Are the shuttle engineers back then? A lot of the personnel, some personnel is transferred over, Drummer. Yeah, like particularly on the launch control team. Charlie Blackwell Thompson is, I'm pretty sure she's launched other spacecraft before. I think Scott Manley found the valve in the schematics, and it is in the stage itself, so you're not alone on that. Saying that, they did say that they skipped this test during the wet dress rehearsal due to the LH2 leak. Well, that would explain your first time encountering it, Tin, right? Yeah. So. Oh dear. So we'll find out here in about 6 minutes what's going on. Yeah, I saw this from Scott. There's a RS-25 diagram. I would have my telemetry. I have the STS-1 log somewhere. It's still packed up. I gotta go find it. Of course, the one thing left unchecked is the one that malfunctions. Of course it is. Yeah, better to find it here. So that's the controller right there. Okay, couple of things here. If I'm looking at this schematic correctly, that's a wire. Hang on 1 second. Cool. Alright, so this is a wire here, guys. I know because that's the avionics controller, and pipes don't come out of that. If they do come out of that, it's conduited pipe on the rocket motor that has wires inside of it. Fluid doesn't come out of that. If fluid is coming out of that, you got a problem. So, if I'm looking at this correctly, this looks like your power wire. Could be, once again, could be wrong on this. And that looks like your controller wire. So, that's your positive. It's grounded on the rocket engine, and then there's your controller right there. There's no negative. It's just positive. So, I mean, the rocket, we know the rocket uses direct current, because alternating current on a rocket would be very strange. So what part of the original engines was upgraded? The avionics controller was upgraded, but the other 3 avionics controllers work fine, Drummer. This is the kind of stuff that I'm talking about. That's the controller right there. This is your control system. The computers for the engine are in there. Think of this like the ECU for the engine. That's the computer that controls the engine. It controls fuel map, mixture ratios. Oh, hold on a second. No. Nope. I'm wrong. Pneumatic control assembly. Does that say PCA on it? It does. It's a pneumatic line. Interesting. The controller's over here. So these are pneumatic lines. Okay, so then it's a pneumatic controller. Interesting. Okay, alright. That's a way to do that. What are they using? Nitrogen. That says N2 right there, right? I don't know what D+4 is. Hey, there's a key. Maybe if we use that, we can figure out actually what the heck I'm talking about. I mean, you don't want fluid in there as well, yeah. Okay, yeah, they're using a pneumatic control. Pneumatic control. Let's see, where's the bleed valves? Pick of the scaffolding at the pad. In the last 45 minutes, a small crane has showed up at 39B and lifted something onto the MLT, possibly the beginning of pieces of the platform needed to reach trouble spots inside of the core stage. Okay. I'll get more into that in a second. Alright, let me see. So, I said that was the avionics controller. The controller's over here. This is plumbing. This is a straight plumbing diagram. But this is a Block 1... This is a Block 1 shuttle motor, but this might not have changed. Then again, it might have. It could be an electric solenoid. It's a pneumatically actuated valve. It's a pneumatically actuated valve on the turbine side here. Yeah, so you want this... But it's... Okay. There's the LPFTP, and that's the HTFTP going in there. Yep. There's the draw. Okay, I see how this is working. Yeah. The teleconference has started. Okay. So what I was looking at with this, dudes, is okay. Now I apologize for not calling that thing right. That's the pneumatic controller assembly, not the avionics controller. So, all right. Here's the thing. They said they weren't seeing the right temperatures, but look at how far this is into the plumbing. See what I'm talking about? This is way past the low pressure fuel turbo pump, LPFTP, right there. It's way after it. Now, don't get me wrong, that's a bleed valve. What this is going to do is bleed the fuel into the nozzle. The reason why you need to bleed the fuel into the nozzle is because of the fuel-rich stage combustion cycle. Also, it uses the hydrogen to cool the nozzle correctly. So they're going to bleed all the way up into the turbo pumps, into the top part of the turbo, well, gas generator, I suppose. The turbo pump is right there. What is this diagram? A shuttle engine. Hey, B0, 20-month resub. Have you 3D printed an RS-25? No. Yep. And there's the hydraulic. That's hydraulic, I think. Guys, this is too far into the plumbing. I'm pretty damn sure. That's way too far into the plumbing. That's my theory. I don't think this is engine 3 related. This has got to be core stage, but the real question is what? Now, what is that? Why am I so curious? Why does it matter? Well, if it's not engine related, well, that means you don't need to go screw with the engines. It could just be a sticky valve somewhere in the core stage. The engines, they have plenty of flight data and research on, right? You got plenty of flight data and research on that, right? So, I'm inclined to believe that because there's so much data... Jeez. Because there's so much data on... That's literally the metal expanding and contracting. I really got to get the roof sorted. Because they have so much data on these engines, right?
Discovery, go and throttle up.
Because they have so much data on these engines, I highly doubt it's engine related. They've reached the shuttle engines have reached a very high degree of development, and they're being successfully used in the operation of no Fortrunians. So, I'm going to go ahead and guess, because the core stage is much newer than the engines, that it's probably something core stage related. Now, why am I looking for that? Why does it matter? If it's engine related, well, you got to start taking apart the engine. You got to start taking apart parts on the motor. You don't want to do that. Nobody wants to do that. Core stage related might be something that they could get at from the MPS. But this configuration is new. What configuration is new? Hey, King Kitten, 77-month resub. What configuration was new? Think about it. What configuration was new? Cough, Saturday. Cough. What configuration was new? That's an honest question, right? Like, it's an honest question. What configuration was new? The only difference in this configuration, guys, is the 4 engines working in tandem. They would have last encountered a configuration that's very similar to this from the green run tests. The engine, it can't be the engines. They already tested those. Wouldn't there be a difference from them being on SLS versus on the shuttle? Yeah. Didn't they change the bleed system from the green run? I'm not sure, Tesla. NASA said the engines were rebuilt to fit SLS instead of the shuttle. So that configuration of those engines has been untested? Nope. What's the only thing that's different? Nice, Sebby. Are we on hold? Yeah. Yeah. Time? Yeah, maybe predominant, right? Let me just fast forward. Prepare to fast forward, chat. Preparing to fast forward. Fast forwarding, chat. It is DMCA free. Oh, if they scrub the conference, I'm gonna be pissed. Oh, we're caught up. It's a built-in hold. Because I know we got a Starlink tonight at 1:40 a.m. Eastern. Ah. Neat. I haven't heard since the scrub, but instrument error was a real possibility. Yeah, Rockets, that's what I'm saying. I don't think it's the engine. It could be the core stage, but yeah. Could have been just bad instrumentation, but then again, I didn't see engine 3's bleed valve opening either. Oh.
Discovery, go at throttle up.
I would now like to turn the conference over to Ms. Catherine Hambleton. Thank you. You may begin.
Good afternoon. I'm Catherine Hambleton with NASA's Office of Communications. After waving off a launch attempt on Monday, August 29th for the Artemis 1 mission, teams have been analyzing the data and discussing options to determine the next steps. Artemis 1 is a flight test to launch NASA's new rocket, the Space Launch System, and to send an uncrewed Orion spacecraft around the moon and thoroughly test the spacecraft systems before missions with crew. Here to talk with us about yesterday's operations and the path forward are Mike Serafin, Artemis 1 Mission Manager from NASA Headquarters, John Honeycutt, Manager of the Space Launch System Program from Marshall Space Flight Center, Charlie Blackwell Thompson, Artemis Launch Director from the Exploration Ground Systems Program at NASA's Kennedy Space Center, and Mark Berger, Launch Weather Officer with the U.S. Space Force's 45th Weather Squadron. We'll have a few opening remarks from each of our speakers, and then we'll take questions from reporters on the phone line. Reporters can enter *1 on the phone to be entered into the queue at any time. First, we will hear from Mike Serafin. Mike?
Okay. Well, good afternoon. Thank you for joining us and for continuing to follow our mission and our program. As you recall from yesterday, we had a couple of challenges that we encountered, and that ultimately ended up in a scrub of the first launch attempt for Artemis 1. The day began with some weather challenges that delayed the start of tanking, and then once we got into the cryogenic loading of the vehicle, we encountered a leak at the tail service mast umbilical on the hydrogen side at the 8-inch quick disconnect. The team managed to work its way through loading the core stage and the upper stage in spite of that leak, and we got a fully loaded vehicle and went into the engine bleed demonstration and attempted to do the thermal conditioning of the RS-25 engines, but we were unable to get the engines within the thermal conditions required to commit to launch. That was something that we knew about coming out of the agency flight readiness review, that we would demonstrate that the first time in the launch countdown, and we knew that that was a risk to being able to successfully attempt a launch that day. In combination with that, we also had a vent valve issue on the core stage, and it was at that point that the team decided to knock off the launch attempt for that day. Since that time, the team has rested, and along with thousands of others, our operations teams, our engineers, and you folks on the call that we're here to follow the mission, folks got a good night's sleep. We came back and reviewed the data from Monday's launch attempt, and met today as a mission management team with our operations and engineering teams at 3 p.m. Eastern Time, and here's what we agreed on. We agreed on what was called Option 1, which was to operationally change the loading procedure and start our engine chill down earlier. We also agreed to do some work at the pad to address the leak that we saw at the hydrogen tail service mast umbilical. And we also agreed to move our launch date to Saturday, September the 3rd. We are going to reconvene the mission management team on Thursday, September the 1st, to review our flight rationale and our overall readiness. So that's where we got to today, and I'll turn it back to you, Catherine.
Thanks. Next, we will go to John Honeycutt from the SLS program.
Okay, thank you, Catherine. Yeah, I know we were all looking forward to having a launch yesterday, and I can assure you there's nobody more ready than to go fly the rocket than I am. We did run into some issues that we couldn't get dispositioned in real time yesterday and get to T0 in the launch window. As you've heard, we were doing what we call a kickstart bleed test yesterday during the test that we had planned on doing during the previous wet dress. We were unable to do that in the previous wet dress because we ran into a hydrogen leak at the 4-inch bleed quick disconnect that the team has since repaired. And so we're in the mode now of processing the data that we got and updating our approach prior to the next launch attempt. And so I'm confident with where the team's headed. I've spent most of the day with the team. The team's been looking at data last night and looking at data today, and based on what we've done with the core stage and the 4 engines at the Stennis Space Center for the Green Run test, I've got a lot of confidence in the design of the rocket. For good reasons, we did implement some differences in what we did during the Green Run. As of today, and based on the data that we've got, we think we can do something like what we did at the Stennis Space Center and put ourselves in a better position for launch. If we'd have gotten this data in the wet dress rehearsal number 4, we would be doing exactly what we're doing now. And so, as you heard Mike mention, and we talked it at our FRR, this was something that we were unable to do in wet dress rehearsal number 4, and it was a validation test that we needed to do. And so we've got a a path forward to get where we need to get to support the next launch attempt. So, Catherine, I'll turn it back to you.
We'll go to Charlie Blackwell-Thompson next, our launch director.
Thank you, Catherine. Good evening, everyone. Let's see, I'll start off and talk a little bit about our launch countdown launch attempt yesterday, and some of the events and that went into that, and then also some of the issues that we observed. So around midnight, midnight on Monday, our team was right on schedule to start the cryogenic loading operations. The improvements that we made from wet dress with regard to what our timelines look like and our loading procedures all worked very well, and we were right where we wanted to be. We got delayed a little bit because of weather, and we certainly have weather restrictions, and I'm sure that Mark will talk a little bit about that. But we were delayed for about an hour from our tanking operations. Once we got going around 1 or so in the morning, we began filling the core stage. Of course, we start out with LOX and then move over to hydrogen. During the course of the LOX load, the lessons learned from our wet dress attempts were great. We didn't have any issues. The improvements that we made in our loading timelines as well as our software, we really didn't talk about anything LOX related yesterday. We did get into hydrogen. Our chill down was all nominal. Our slow fill was all nominal. When we got into fast fill, we did notice that we had an indication of some hydrogen in the TSMU purge can, and the team was able to adjust the flow rates during that operation and manage our way through the loading ops. But we did see some indication of a leak in the purge can. We managed through that. We really had a fairly uneventful upper stage load, so that was good. We got through our upper stage loading, and then, of course, as part of our plan was once we got to replenish on the core stage, we were going to do what we call the kickstart bleed. And we put those operations into work, and we did see that we had one engine that was reading a little bit out of family from the others. I know we're going to talk a little bit more about that. And so we had initiated some troubleshooting to try to resolve that, to try to bring that temperature back in family with what we were seeing on the other engines. Ultimately, that was not successful, and when we started to look at that, along with the timelines for additional troubleshooting, we were really with outside the bounds of being able to attempt within the window, and we went ahead and called the scrub for the day. The team did continue to do some data evaluations after that, gather some data at cryogenic conditions, and then a little bit later in the morning, we got into our drain operations. So since our scrub ops, our team has finished up our safing. The vehicle was drained, and we spent some time today talking about our go-forward plan and put that together. And I know we're going to talk a little bit about that. I know John's going to talk a little about the engine piece. I'll talk about some of our near-term activities related to the LH2 TSMU and the leaks that we saw there. We do intend to go ahead and, at the pad, open up the purge can on the back of that plate and take a look. We want to do some inspections, we want to do some retorques, and we also want to make a change relative to the purge going into the plate. And we can do all that while we're out at the pad. We're already getting access set up to start working that.
All right. Next, we'll go to Mark Berger, our launch weather officer.
Good evening, team. So kind of recapping what happened yesterday, the first issue arrived just before tanking. One of the constraints that we have weather-wise is that the threat of lightning within 5 miles of the pad must remain at or below 20%. Given some thunderstorms developing offshore, I wasn't comfortable with that threshold being met and offered a 40% chance of lightning within the pad. And those conditions continued for roughly an hour, delaying the tanking. We did not ever actually register lightning within 5 nautical miles, but we did have it about 7 or 8 nautical miles from the pad at closest approach. And so from that point onward, for a good balance of the remaining of the tanking, weather was pretty quiet. However, shortly after sunrise, we did start seeing on radar new showers and storms developing to the southeast, and those were being moved northwestward, and unfortunately did enter our constraint violation for weather right about the time that our launch opportunity T0 commenced. We were no-go for various weather concerns for roughly 3/4 of that window. However, we did clear all weather violations in the last 1/4 of the window after the launch attempt had already been scrubbed. Looking forward to Saturday, weather will be a little bit different than what we experienced yesterday. We will have a fairly strong onshore flow, and so that does favor showers and possibly a few thunderstorms moving in from the coast during the morning and early afternoon hours, so we'll have to watch that as far as tanking. But otherwise, typically with that kind of regime, we tend to have the sea breeze pushed well inland, and that's the main focus for shower and thunderstorm development during the afternoon, including the window. So I'm optimistic that we'll have at least some clear air to work with during the afternoon attempt on Saturday. However, again, the probability of weather violation at any point in the countdown still looks to remain rather high, just again, given the moist air mass and that fairly moist fetch of showers coming in off of the ocean.
Thank you. We'll now go to questions from reporters on the phone. Once again, please press *1 to join the queue. You can press *2 if your question is answered or you want to be removed from the queue. Please do state your name and to whom your question is directed, as well as your affiliation. And we do have quite a few questions in the queue, so we please ask that you stick to one question so that we can get to as many questions as possible. So first up, we'll have
How
Martha
much did
Dunn
this
from
cost?
Associated Press.
Yes, hi. Can you hear me?
Yes, thank you.
All right, so
Yes, for John, please. You mentioned that you repaired the 4-inch quick disconnect. That it sounds like that there was a 4-inch quick disconnect that was preventing the chill down of engine 3. Is that the one you're referring to that was repaired, and what was wrong with it, and how did you fix it? Thanks.
Yeah, so I will say yes, that did occur during wet dress number 4.
Yeah, that's not the same system.
I referred to that as we wanted to get this engine bleed kickstart test done during wet dress number 4. That is, we do need the 4-inch QD, which does tie into the vehicle hydrogen bleed system. In order to do the test. We did have that leak. We violated some requirements, and Charlie and her team worked through that, and then we worked through the repairs. Charlie, your folks did most of the work on the repair. You want to talk about that?
Well, on the 4-inch, we actually went in, if you recall, and we changed seals. We did the inspections, and I will say that yesterday we had that. When we go into Kickstart, we utilize that interface, and that interface was tight yesterday.
Yeah.
So the work that we did after wet dress 4 to fix that was successful.
Yes.
Thank you. Our next question is from Bill Harwood of CBS News.
Yeah, thank you very much, guys. You told us you're going to change some procedures, but you haven't told us what you're going to do. Can you please walk us through the chill down process? In other words, my understanding is this is a pressure-fed system on the hydrogen side. You don't have pumps like you did on the shuttle. I've heard that the line going to engine 3 is longer than the others. I'm wondering if that's true. And how do you know you're getting liquid at the engine and it hasn't turned to gas? I just want to know how that process works, because I don't understand how you're going to get the engine back in the box you need for launch. If you could give us some of those details, I'd really appreciate it.
Yeah, Bill, good question. I'll try to outline that, and Charlie will probably have to help me out a little bit. But the configuration we've got is a lot like shuttle in on the main propulsion system with a couple of exceptions. One, we've got 4 engines instead of 3. And then on the shuttle system, we had each leg of the hydrogen feed system in the shuttle going to those 3 engines on the shuttle had a recirculation system in it. So that enabled us to get that that warm gas pumped back into the hydrogen tank, and then it ultimately boiled off. From a hydrogen loading perspective, it's pretty much the same as we did in shuttle. We go through a phase where Charlie and her team chill down the facility, and once we get into that, we start into the vehicle chill down, then get into slow fill, transition into fast fill, then transition into topping, and then ultimately get into replenish in a vented phase. And so the design change from shuttle to SLS and the MPS system that gets us to where we need the bleed system is we're carrying all. We want to take that heat out of the engines and overboard. So instead of being able to dump it back into the hydrogen tank and let the hot hydrogen boil off and go to the top of the tank and out through the vent, we're sending that heat that comes from the engines out through the ground vent system. So that's the big difference in the configuration and how we load. Now, what we did, what we wanted to do in this engine bleed kickstart was use some temperature data on the vehicle to validate that we got good temperatures, liquid hydrogen flowing through the bleed system on all the engines. Engine 3 obviously is further away. It's the furthest one away from the bleed connection to the ground. However, we designed all 4 bleed lines that tie into the system manifold to have the same resistance as each other. So we don't see any difference in that's driving anything specifically for engine 3. Now, what we saw in the test yesterday, we wanted to drive all the temperatures down to roughly minus 420 degrees Fahrenheit. And we didn't get there on any of them. We got close on engines 1, 2, and 4, but we didn't get there on as close on engine 3. We isolated 3 to itself by closing the pre-valves on 1, 2, and 4, where we had flow going just through engine 3, and we still didn't get a good temperature measurement. So ultimately, what we're seeing is some positive data in the pressure measurements that we're seeing, some goodness on 4 of the engines, and a temperature that just seems totally out of bed on engine 3. So we are questioning the fidelity of these sensors. These sensors are not flight instrumentation. They were designed only to be development flight instrumentation, and so we're a little bit concerned about one of those sensors. But one thing I can tell you is that we're really seeing some goodness in the data and what the physics is telling us, in that that when we do establish that bleed flow in the vehicle and out through the umbilical into the vent line on the ground, we're seeing good cold liquid hydrogen. So then I'll tell you the other thing that's different about what we did at Stennis and what we did here at KSC yesterday. At Stennis, we initiated the bleed test early on in fast field. The engines weren't as chilled down as they were yesterday, and we did get good results. However, we did have a little bit higher fidelity instrumentation on the ground during the test at Stennis. That is the only operational difference in what we did at Stennis versus what we did here yesterday. Now, the reason we waited to do the kickstart test yesterday is, and you've heard Charlie talk about how precious our commodities are in LOX and hydrogen, is the technical team felt like it was all in the direction of goodness to wait until we got into replenish. We would have a full hydrogen tank and have it nice and cool and densified, so that when we did run the bleed test, we would be even in better shape. The engine bleed system is different also. That since we did have to redesign the vent relief system as part of the engine bleed system after the green run, because we realized we didn't have the right tubing size to meet the maximum working pressure for the design. Changed it out to a bigger line. Bigger line intuitively is goodness. Also, there's a difference in Stennis and here at KSC. We had a smaller hydrogen vent line on the ground, and here at KSC we got a larger vent line, and it is insulated. So all those things are in the direction of goodness of having good cold fluid. I think where we are today is, I think we've got enough data to put the story together, but we've still got to go put the pieces together. Charlie, you want to add anything to that?
I can't think of a thing to add, John.
Thanks, John. Our next question is from Chris Davenport of the Washington Post.
Yeah, thanks, and thanks, John, for that explanation. That helps a lot. I guess I'm just wondering if it sounds like the main thing you're going to change is to start the bleed test earlier, like you did at Stennis. So I'm just curious how much earlier you will start to do that. And if I'm hearing you right, it sounds like you had liquid hydrogen going through that engine 3. It reached the engine. You just weren't getting the temperature somehow that you wanted, and maybe that was a bad sensor. Is that right?
What I'm telling you is the data on the ground side looked that way, but on the vehicle side, especially for engine 3, it did not reflect that. And Charlie, you need to probably answer the one on the timeline if you think you can. I think you get better off at that than I am.
Yeah, so I was actually just pulling out my bar chart to take a look at exactly how much further. As John mentioned, right, we go through various phases of loading. We go through the fast fill, then we go through topping, and then we go through replenish. I'll get you a time here. Just let me do some quick calculations. But we will be pulling that back earlier into the fast fill operation, somewhere, in and around the 15 to 20 minutes in. So, I mean, it will be coming back for some period of time. And like I said, so give me just a minute before we end this. I'll give you where I think how much earlier that is.
Thanks, Charlie. We'll go ahead and take our next question from Kenneth Chang of the New York Times.
Hi, thank you. This is for John and Charlie. It sounds like one strong possibility is that it's a bad sensor, which suggests you might get the exact same readings on Saturday. Do you have rationale for going forward with launch? Or how do you decide whether to go forward with launch if you believe that it's just a bad sensor and everything's actually good.
Yeah, so based on what I've heard from the technical team today, what we need to do is continue to pour over the data and polish up our plan on putting the flight rationale together. I think we've got enough data to do that, but we'll have to let the data guide us.
All right, thanks. We'll take our next question from Irene Klotz of Aviation Week.
Thanks, Catherine. So, John, just to clarify, you're saying that you think that if you had done the kickstart prior to the LH replenish yesterday, you might not have had this problem?
I guess no, Irene, what I'm saying is the only thing that I know to change to replicate the success we had at Stennis is moving the test earlier in the timeline and changing a couple of variables. One, the timeline. Two, the engines will be around ambient temperature. And we did see that work at Stennis.
Thanks. And I don't know if I missed this, but did we actually get a percentage of the weather for a launch attempt on Saturday?
Hi, this is Mark. So right now it looks like the probability of a weather violation during the count will be somewhere in the neighborhood of 60%. And while that is a fairly high number, the reality is with this kind of onshore flow, typically these showers are quite sporadic as they reach the coast. So while I would expect us in all likelihood to have at least some threat of a violation during that 2-hour window, we have 2 hours to work with, and these showers tend to have quite a bit of real estate between them. So I still think we have a pretty good opportunity weather-wise to launch on Saturday.
Thank you, Mark. Our next question is from Nell Greenfield-Boyce of NPR.
Hey, can you all hear me?
Yes.
Okay, sorry to belabor this. I just want to make sure I totally understand. So it sounds like you can't see or think of anything physically different about Engine 3 that would explain why it didn't chill down the way you expected and the way you all had seen at Stennis. And the sensors you have on the ground make you think there is liquid fuel coming through. And so you think it might just be a dodgy sensor. And so you're going to start doing this earlier in the countdown next time. And you may decide that if things look good, you might go ahead with the launch. But right now you don't know that yet and you're thinking about it. Is that accurate enough?
You got it pretty much, with one exception, is we will have a plan for a no, rather than us sitting around and scratching our heads, was it good enough or not? And so that's what we got to finish. We got to continue pouring over the data. We got to put the flight rationale together, anticipating that we're not going to get any better results on that Engine 3 bleed temp sensor.
And I guess I would probably add, this is Charlie, that, one of the things that we've talked about over the course of since yesterday is, it makes sense to us as a team to replicate what we saw work at Stennis. And so that's the reason that we would look to go pull this, this kickstart back, if you will, so into the fast fill time frame. And I did go look that up while we were talking, and that does mean we would do it about 30 to 45 minutes earlier than we had done.
Thanks, Charlie. Our next question is from Kristen Fisher of CNN.
Thank you. 2 questions. One is just kind of scheduling. Can y'all please confirm the exact launch time?
Put
for
your
Saturday,
windows up.
the length of the window, and if Saturday is scrubbed due to weather, when the next launch attempt would be? And then I have one more quick one, please.
Hi, Christian. Yeah, so the the launch time for a Saturday attempt would be 2:17 Eastern Time is the window open, and it's a 2-hour window. And I'll turn it over to Charlie to talk the scrub turnaround.
Yep, so the scrub turnaround, as always, will be driven by the reason that we scrub, but assuming that it's a weather scrub and we're not looking at any kind of technical issues, it's just commodity turnaround, then we could be ready as soon as 48 hours later. That would put a Saturday, Monday in play.
Thank you. Our next question is from Micah Maidenberg of the Wall Street Journal.
Hi, can everybody hear me okay?
Yes, we can.
Okay, great. I don't know if this is for Mike or for John or for Charlie, but just given some of the unknowns and some of the work you're still doing, what are the risks of kind of moving forward? You talked about option one, but is it the most risky one versus just simply rolling it back and looking at everything in the controlled facility, the VAB? Thanks.
Yeah, so Micah, we did kind of talk about the spectrum of options, and we are at the pad right now, and the rollback scenario could have essentially put us in the exact same posture that we find ourselves in right now, which is we may just need to change the operation slightly and the cryo loading slightly, as well as address this tail service mast umbilical leak, and we can do that at the pad or in the VAB. So we elected to proceed to do that at the pad. The other option that we discussed at length was whether or not we should do a dedicated test associated with exercising this hydrogen bleed, and there were some pros and cons to that. The cons were that it would put additional cycles on hardware with limited benefit. There was some benefit from an engineering standpoint, but in terms of our ability to execute the operation and get to a successful launch attempt, there were limited merits to doing that. I don't know, John, if you have anything to add on that, but we did kind of talk through that spectrum of options. Okay.
Thanks. Our next question is from Ramin Skiba of Wired Magazine.
Hi, thank you. I have a dumb question. I guess this is for Charlie or Mike, but I just want to know exactly what is an engine bleed, and is that the issue that has led to a Saturday rather than a Friday launch attempt?
Yeah, so this is John. I should probably take that one. Yeah, and so what you want to do in a rocket engine system that uses hydrogen as a fuel and oxygen as an oxidizer is you need to establish a way to make sure you chill down the engines. And so in kind of auto racing, drag racing type terms, you don't ever see those cars go out on a racetrack or a drag strip without a good period of warm up. And we're similar to that, but what we need is to get the engines nicely conditioned so they're cold. And the way we do that is we send the liquid hydrogen out of the hydrogen tank to each individual engine that has its own bleed system, which is used to take the heat out of the engine as we chill it down.
Okay, thank you. Our next
Car
question
analogies,
is
baby.
from Michael Greshko of National Geographic.
Hi, thanks for doing this. Yesterday we heard that you all were aiming for a chill down for those engines to 500 degrees Rankine, or just above 40 degrees Fahrenheit. John, could you speak to how close the engines actually got to that as reported by the SLS sensors? Not just engine 3, but 1, 2, and 4 as well. Thanks.
Michael, this is Mike. I'll just say right up front, I misspoke on that one, and then I'll turn it over to John. I misquoted a number, and I shouldn't have done that.
Yeah, so where we wanted to go was approximately 40 degrees Rankine. I mentioned earlier we converted that to Fahrenheit for folks, and so it's minus 420 Fahrenheit. Engine 3 was probably about 30 or 40 degrees warmer than engines 1, 2, and 4, and I'm kind of just pulling it off the top of my head without looking at the data plot, but I'm kind of thinking that engines 1, 2, and 4 were probably around minus 410, something like that. Yeah, so 1, 2, and 4 are pretty close. The temp sensor on engine 3, its indication was a little bit warmer, 40 degrees warmer. So about minus 380.
Thank you. All right, our next question is from Tom Costello of NBC News.
Hi, guys. Good afternoon, and forgive me for re-asking one question. Somebody's cell phone, maybe mine, distorted at the very moment you were talking about what happens if you don't go Saturday. So could I ask you to indulge me? What happens if Saturday ends up not being a possibility? Thank you.
Hey,
I like that
Charlie.
guy's voice.
I can take that one. You know, with all scrubs, it depends on the reason you scrub. That really drives your turnaround, but provided that it was a weather issue, we are driven by replenishment of our commodities, hydrogen being the primary driver, and we could go as soon as Monday. So 48 hours in our turnaround.
Thanks, Charlie. Our next question is from Jeff Faust of Space News.
Good evening. Question for John Honeycutt.
My name
is there
Jeff.
any history of temperature sensors malfunctioning in a way that they're off by 30 or 40 degrees versus simply not operating at all? And when were the last time these sensors calibrated and checked? Thanks.
As far as calibration and checked, I'm pretty sure that we didn't do it anymore after it left the factory. So it's been quite a bit ago. As far as just history on sensors, over the course of my career, I have seen many sensors on launch vehicles be erratic and work and not work and go out of calibration. So it's not terribly unusual.
Thanks, John. Our next question is from David Curley of the Discovery Channel.
Thanks very much. What are the margins? If you were at 410 on 1, 2, and 4, is that good enough? And do I understand correctly, by starting this earlier, why would you know if the sensor is malfunctioning? Will your flight plan just say if we're seeing it come out on the ground side at a cold enough temperature that we feel confident that it is a sensor?
Yes, I've shared with you what I know so far, but also I'll remind you again that the team is in the middle of pouring through the data and building the flight rationale. So I don't have that just yet, but I do expect us to be able to get there.
All right, thank you. Our next question is from Jasmine Julmis of WPBS. It looks like we lost Jasmine, so we'll go to Eric Berger of Ars Technica.
Hi, thanks for doing this. A couple questions. First of all, for Mike, would you characterize this as a wet dress with a possible attempt at launch, or is this a full-fledged launch attempt?
Jackass.
And, I just would love to hear your confidence in sort of reaching, T-0. And then for John, I'm sorry to belabor this, but when you talk about flight rationale, does that effectively mean you're inferring the temperature of engine number 3 from other data such as pressure readings or ground-based sensors? I'm just trying to understand, what's going to give you the confidence you need in engine 3's temperature. Thanks.
Yeah, Eric, we are going to try to launch on the 3rd, and coming into this prior attempt, yesterday's attempt, we said that if we couldn't thermally condition the engines, we're not going to launch, and that's the same posture that we're going into Saturday on. I don't see it as any different.
What a putt! Oh my goodness!
Yeah, Eric, I understand your question, and I'm in the middle of, and the team's in the middle of a big data exercise and an analysis exercise. I think, we understand the physics about how hydrogen performs, and it's not, the way the sensor is behaving doesn't line up with the physics of the situation. And so we will be looking at all the other data that we have to use it to make an informed decision whether or not we've got all the engines chilled down or not.
Thanks, John. Next question is from Joey Roulette of Reuters.
Thanks. I guess this is for Mike or John. What, if anything, I guess, would warrant calibrating and checking those faulty sensors, and what would that entail, or how long would that take? And also, what is going to be done, I guess, to address the leak in the tail service mast? Thanks.
Yeah, so Charlie probably can speak a little bit to both of them, but I do think an R&R of the sensor would cause us, we'd have to do a rollback to that to get access into the engine section.
And R&R of the sensor would, while we can gain engine section access out at the pad with some temporary access, it's likely not ideal. So that would be, I would say, some impact that would take us outside of launch period 25. With respect to the tail service mast and that purge can, as I said, we are already putting the access up at the pad to get into that. We believe that once we get access, we have about a shift and a half, 2 shifts worth of work, and then of course we have to button everything back up. But part of that work is to go in, check the torques on that flange, do an inspection, see if there's anything there, do some leak checks on it, and then we're also making a purge modification in that area.
And that's remove and replace for the R&R, correct? Thanks. Our next question is from Alicia Sowers of Mashable.
Hi, thank you. A question for John Honeycutt. So if you're questioning the integrity of this sensor, is there a potential to replace the sensor? Was that discussed, rather than trying it again, possibly getting another off reading, and then, still not knowing if the temp is really off? Thank you.
Yeah, so as we mentioned, replacing the sensor at the launch pad would be tricky. Charlie just told us that we could get access, but it's not ideal. And so the only other alternative there is a rollback. What I would like to do, and what I plan to do with the help of the team, is put us in a situation that gets us the data we need to know that we've got the engines chilled down appropriately and go fly using the data that we've got access to today.
Thanks. We've got time for a couple more questions. We'll go to Emily Speck from Fox Weather next.
Hey, thanks for taking my question. My question's for Charlie. So with the weather delays and technical issues, it sounds like there just was not enough time in the countdown on Monday. On Saturday with this new plan, how confident are you that there will be enough time to work through any issues that might pop up?
Well, it depends really on the issues that pop up. So that's really tough to say. You know, what held us up on our attempt on Monday was the fact that we got a late start due to weather. And so then we, you know, our tanking timeline pushed into the window, and then we had a technical problem that to resolve that technical problem required more time than what we had in the window remaining. So it really all depends on, you know, when we have a weather issue. If we got started tanking on time and the weather wasn't an issue at tanking, then certainly, you know, we would have the balance of the window, which is expected to be about 2 hours to go resolve that. But it's tough to speculate because it all depends upon, you know, when we get the weather issues and what that impacts.
Thanks, Charlie. Our next question is from Gina Sinceri of ABC News.
I'm not sure who this question is for, but these engines flew on space shuttles. Are you expecting different performance from them on SLS from the shuttle? I'm just kind of trying to figure that one out.
Expecting similar performance. We're running them at a little bit higher power level, but expecting similar performance.
Thanks, John. Our next question is from Chris Gapehart of NASA Spaceflight.
Hi, thanks so much. A couple of questions for Charlie.
Save us, Chris.
One, I haven't heard anyone talk about the vent valve, the intertank vent valve that malfunctioned yesterday and prevented you from pressurizing the hydrogen tank. What's the status of that, and how confident are you that it will work on Saturday, and if it does close, that it will stay closed after it leaves the pad to maintain that pressure during flight? And also to this engine issue, how do you essentially, if you get into Saturday and you see the same temperature issues on engine 3, how do you essentially mask that from the ground launch sequencer and the ALS and the main engine controller so that they don't freak out when they go to light the engines and trip and abort after the engines start? Thank you.
Okay, so I'm going to start out, and then I'll have John Honeycutt add in here anything that I may miss. So when we talk about the issue, what I like to refer to as upstairs, right, the leak that we saw, I want to be really clear. We didn't have an issue with the vent valve, right? We had an issue with the intertank vent QD seal, right? So we have on that umbilical, we have a hydrogen vent up there, and it was in that cavity. So not totally unlike maybe what we saw in the TSMU. So we detected that we had a leak. Keep in mind the configuration that we were in. We had that area had gotten really warm just based on the configuration of the tank at the time. So when we got into some of our troubleshooting and we decided that we were ready to change configuration, it was very warm, and then you hit it with a very dynamic event. And so we believe that was part of what, you know, we have historically seen on shuttle and on this vehicle, that one of the things that can happen is that you can see some performance differences in your QD as you warm them up and as you get them cold. In fact, that's one of the ways in which we troubleshoot when we have a leak, is we allow something to warm up and then we hit it with some colder cryo temperatures and see if we can get like a QD to reseat that way. That's part of our troubleshooting plan. So we had it sitting there, it was very warm, and then as we got into the follow-on operations, we hit it with a very dynamic event, hit it with some very cold temperatures, and that's when we actually detected the leak. So we're pretty confident that it has to do with the fact that that the QD warmed up over the 3.5 hours with the full tank, and then we opened it with very saturated tank at a higher pressure. And so what we also saw is after we got into some of our later operations and you started to see the pressures change, that leak went away. And so we believe that it was very reflective of where we were at the time, and we don't expect to see that on our next launch attempt. And let's see, the other question I think was on
How you gonna mask my temperature?
Oh yeah, the temperature. So I wanna talk a little bit about I know John talked about what his team is off doing. We have on this bleed interface, we have a temperature that we look at for each of the 4 engines, and that's the one that John talked about. We also have a temperature on the ground side, right, that is what we would call downstream of those bleed interface temperatures that are on the vehicle. And we have other temperatures and pressures, across the engine. So there's a suite of data. And so what John's team is looking at, and what our team is looking at with his team, is what set of data do we have available to us, not just limited to the single piece of instrumentation, that can help us establish that we have good flow across those engines. And once the team has reviewed that and they brought that forward, then we would implement that as part of our plan. It could be the same plan that we had on Monday. It could be a different plan. But we would go through, we would review that, we would practice that. Happen is as part of our plan. It could be the same plan that we had on Monday. It could be a different plan. But we would go through, we would review that, we would practice that, and really it will all be data driven. The team's looking at the data. They will come forward if there are any changes to this particular launch commit criteria. And then we, of course, would go look at how to implement that within the ground launch sequencer, and we would go practice that within Fire Room 3.
Thanks, Charlie. And that's actually all the time that we have for today. Thank you all for joining us. You can listen to a replay of this teleconference online shortly. It will be posted on the Media Resources tab at nasa.gov/Artemis-1. And you can watch a live stream of the Rocket on the Pad at the KSC Newsroom YouTube channel. And of course, you can follow along and learn more about the mission at nasa.gov/specials/Artemis-1. Thank you all again, and have a good evening.
I have thoughts. Some of them I probably shouldn't mention because, yeah. Can we get a quick synopsis of the whole thing? I joined in late. Sure. Some of them, Slayer, yeah. Some of them should have asked about the durability of the tanks in cycles, as well as the SRB lifespans. Jared, the tank can be tanked 22 times. They're nowhere near that. They're nowhere near it. So the first thing is that the flight is now on Saturday at 2 p.m. I'm not entirely sure why NASA was saying the next attempt is Friday and Monday, but okay, we're looking at a launch at about at 2 p.m. on Saturday, and that should do us right here. Let me look at the PDF for launch windows. Okay, so the 3rd or the 5th are ideal launch windows, guys. They can launch here. They could basically do it. They could go Thursday, Friday, Saturday, Sunday, Monday, Tuesday. Now, what do these different things mean? The gray basically means not ideal conditions to launch, meaning the moon isn't in the right place. The green ones are okay windows. They're okay windows for meaning the moon will kind of be in the right place, but it won't be they need more delta V to get Orion where they need to go, so it's a short duration mission. Red obviously is the least ideal. Yeah, there we go. So the red is the performance available, but Orion won't be able to make it to its destination. Yeah, see, here we go. Green is the long duration mission, and like regular green, and then light green is the short mission, and then gray is no mission available. That's it right there. So they want the most ideal conditions. Yeah, it can't be in an eclipse for too long because of the solar panels. That's correct. So, yeah, we got a couple of days here where it would be good. Yeah. Yeah, they could basically go all the way to Tuesday. 22 cycles for the core stage, although SRBs are 18 months past stacking. Yeah, I would... Screw me for assuming, but I would go ahead and say that they would... I'd go ahead and say that they would very, very much... If there was any inkling that the SRBs weren't going to perform as expected, they would probably say screw this. Yeah, Orion doesn't have any fuel cells. You gotta remember, it's not designed to operate in this close proximity to planets. Friday was the earliest they could have gone if they had a scrub on the 29th. Monday was the earliest after a Friday scrub. That's correct. So, yeah, okay. What's going on? So, long story short, NASA was getting differential information on temperature regarding the chill down rate of engine 3. What does that mean? The ground-based sensors were reading a nominal, the flight-based sensors were reading a nominal reading, so something that's right, but the ground-based sensors were not reading something right. I may have gotten those backwards. Sorry, I've only listened to it once. I listened to the same thing that you listened to. So, what does that mean? Well, if you're getting differential sensor data, signs point to a bad sensor. But the gist of it is that NASA hasn't been able to crunch the data to be able to prove, or to check the hardware, to get their hands on the thing to prove whether that's whether it's conclusive, whether that's one thing or the other. Yeah, the ground side was not right. The sensors on the vehicle were right, but on the ground side weren't. Ground base said good, SLS said too hot. Ground readings were correct. So okay, is it? I'd have to go back and look. Long story short, guys, it doesn't really matter. One of the sensors wasn't right. It wasn't reading the right data. It was reading 390, about 30 degrees too warm. Why is that a big deal? That means there's gas in the engine. You don't want gas in the engine. The real easy way to sum that up is it's a liquid fuel engine. Gas comes out the bottom. You don't want gas going into a liquid fuel engine. That's the real easy way to say it. Liquid fuel engine should take liquid, not gas. So if there's gas in the lines before the part where the liquids mix and make gas, the engine is not going to perform as you thought it was going to perform because you put gas in a liquid fuel engine. And I want to be clear, when I say gas, I don't mean gasoline, I mean gaseous hydrogen. SLS was bad because they said they would have to roll back to change out the sensor. So, does that mean there's a bad sensor? They don't know. It's hard to say. Signs would point towards a bad sensor, guys. But here's the other thing that John Honeycutt said. Here's the other thing. They tried something different for this test. Meaning the bleed cycle was at a different point in the countdown timeline than the green run. This thing up here. Before, they did the green run during liquid hydrogen fast fill. Now, they did the engine bleed during liquid hydrogen fast fill on the green run. On the launch attempt on Monday, they bled the engines during replenishment. So what does that mean? There's 3 types of flow rates that you get for fueling a vehicle. Think about it just like pump speed. Now why? Why is there 3 types of flow rates? Well, 1, you're moving cryogenic propellants. It's the same reason why they bleed the engines. You don't want gas in the lines when you're flowing fluid around, especially really cold fluid. So they have to slow fill the hydrogen first. You gotta slow fill it. You got to start out slow, because if you flow fast into a warm pipe, that hydrogen will evaporate and it'll become gaseous hydrogen, and that's how you make leaks. Leaks will form, which is basically what they encountered during the wet dress rehearsal, more or less. So you want to make sure that the pipe is thermally conditioned correctly. So they slow flow, okay? Slow flowing basically gets the tank maybe 7 or 8% filled from what I saw during because they showed the data on the screen. Once they're sure that no hydrogen is evaporating inside of that pipe, then they switch to fast fill. The other thing is that they start filling up the tank because they want to be absolutely sure that that line is at temperature and flowing hydrogen. There's no gas stuck in the line. They basically bleed the fuel lines. Every rocket does this. Every rocket using full cryogenic propellants does this. Starship does that. Everyone does that. From there, if they bleed the line all the way through, then now I'm talking about the fuel lines that go like into the rocket. They go into the main propulsion system and up into the hydrogen tank. Once they're sure that the line is bled, basically, they use temperature to figure that out. It has to read for hydrogen, you're probably, I think he said minus 420 Fahrenheit, which is minus 250 C. It has to read that. That's how you know you're flowing liquid. They use temperature to figure it out. Because hydrogen only exists in as a liquid in a very nominal temperature range, and it's like 420 to 422 Fahrenheit. I think that's right. 423 maybe or something. So what that does is, if they're sure that the temperature readings on the pipe are reading correctly, that means the hydrogen gas is in the tank, and that means it'll get recirculated out. Which is another line on the tail surface mast umbilical or no, it's not another line on the TSM. They have a swing arm that will vent, similar to the gut on the shuttle. It's a hazardous gas vent line that leads to the purge flame, basically. So they slow filled the tanks, and then they fast fill, which means the line is primed, and then you fast fill. Right? Fast fill is basically moving the most amount of hydrogen. And then the third flow rate is replenishment. Now, because you're dealing at pressure, you're dealing at above sea level pressure here inside of the tank. You're dealing with a higher pressure and a liquid at extremely cold temperature. That screws with the boiling point. This is basic physics. Physics 101 here. Water likes to boil at 1 bar at 212 Fahrenheit or 100 C, right? Water likes to boil then. What happens if you live in a high altitude area? What do you have to do? Lower pressure increases boiling point, right? You have to boil stuff for longer if you live in Denver than you do if you live in Boston, because Denver is 5,000 feet that way, or about 1,600 meters, right? So the propellants are constantly boiling. Once they fill up the tank completely, that liquid hydrogen is boiling, and that's what replenishment mode is on SLS. That's the third flow rate for their pumps. There's replenishment mode, because that hydrogen will start to boil off into gas, even though you did all those things to bleed the lines, you did all those things to make it all nice and dead, it's still going to boil. That's why they have that scavenging system and the purge flame sitting out at the pad, to get that gas, that hydrogen gas that will eventually form no matter what. Replenishment is the rate for the hydrogen, is the rate at which it boils off. So those are the 3 levels for the pump. Okay? Now, during the green run, they bled the engines during high flow, during fast flow. During Artemis 1's first launch attempt the other day, they bled the engines during replenishment. So, point is that they changed something. This is why the press asked so many questions about, what do you think, it's a bad sensor? And why NASA was like, I don't know. They changed the way they bled the engines from the green run. I'm not sure exactly why they said they did that. I think Charlie Blackwell Thompson said it was because of commodities. They wanted to try and save some hydrogen. I don't know why you would want to save commodities and change the way you fuel the vehicle to save commodities. I'm sure there's a good reason. But they changed that's why we got a different result than the green run. I was saying this before the press conference, the only other time they went through this entire thing was the green run, and the green run worked. And I assumed that they would do the exact same thing as the green run, but they did change some things. I'm not sure I'm 100% for doing something like that. That's kind of, but it is a test flight. But also, test flying like this is about validation. You need to validate your tests on the ground. If you don't mimic your test on the ground, the validation isn't worth it. That's the question I would have asked. Yeah, I understand commodity. I understand one. This is the question I would have asked. But I see, this is why I don't ask questions. I have to sit there and I have to go through the data in my head. I have to go through the information presented. I never ask questions because a lot of you only have a short amount of time to be able to ask questions. The press conference isn't going anymore. So that's why you get a lot of reporters that get the information presented. They don't have time to think about the data, and then they end up asking a bonehead question. At least the guy from Wired knew. He's like, yeah, this is a stupid question, I know. So do not do new things on race day. Bingo, Northern. They also upgraded the bleed line to a larger diameter after the green run. I think John Honeycutt said that the bleed line at KSC was different than the one at the green run. Once again, I'm not 100% sure why the hell you'd do that. Yeah, see, Raga guy, that's what I was gonna say. On the flip side, this is a test flight. Now is the time to screw with the procedures. Now's the time to test the new procedures they have practiced pre-launch operations. I would ask something like, when was this change in standard operating procedure introduced? Have they been practicing this for the last several months, or was this on the fly? Bingo. I don't know why you would change that. Has it been practiced? Did you take this into account? Why would you do something like this? That doesn't make any sense. You wouldn't want to deviate from your testing. I mean, that's not generally a good idea. Does each engine have its own system, or are they tied together from one? They're tied together from one. They're all tied off the tank. Well, you have to trickle the propellants somewhere. The pre-valves on the core stage, the pre-valves on that core stage lead to a manifold. It looks like an intake manifold on a car. And that manifold goes to all four engines. The locks there, and then there's two Y-pipe manifolds in the MPS that come from the two downcomers from the LOX tank. So did they fill the whole tank to test the complete tank, or just fill it some and then stop? They tried to bleed the engines when the pump system was in replenish mode and the tank was completely topped off. They did not do that during the green run. During the green run, they tried to chill the engines in fast flow when the tank was half full while they were filling it. They bled the lines down while they were filling up the tank. I don't know. Once again, that's the question I would ask. Why did you change the procedure, and when did you decide this was a good idea? I'll be 100% honest with you, fellas. That goes against everything that I've read about systems engineering. Do not do that. The whole point of testing is the whole point of doing a flight test is to validate your ground test data. And if you do something different, if you deviate from the ground test to the flight test, well, it's going to be harder to correlate and validate that data. I mean, obviously NASA's can read ones and zeros. They obviously thought that this was a good enough way to do this and this wouldn't screw with the data too much, but then again, the engines didn't bleed. Now, did they? So the answer is both, tied to one, but the common interface they are all independently governed as well. Yep. Maybe it was due to the fast flow anomaly. Then they switched back to a backup procedure. Well, Mab, that fast flow anomaly that they ran into. See, I have a theory. I can't prove it. I can't prove it. So, my guess, this is a guess, but NASA's kind of shaken my judgment here because they changed stuff between ground test and flight test. My guess is that, we knew that they were going to run a test during fueling operations for the Artemis 1 launch campaign on Monday. We knew they were going to change something. All right? Because during the last wet dress rehearsal, during wet dress rehearsal 4, they kept having leaks in the tail surface mass ground umbilical carrier plate catch can assembly. Remember how I told you that when you try to bleed down a line, even bleeding the lines going into the rocket, let alone bleeding the engine plumbing, you will have gas that does evaporate. It will leak. There are catch can mechanisms at the flanges, basically where the tail surface mass umbilical carrier plate connects to SLS. There's a catch plate there that leads back into the circulation system and back to the purge flame, or forward to the purge flame, I guess, if you're talking about flow. Because of this, that's a place for gas to leak. It will leak, and they knew that it was going to leak. So they tried it the first time, and the catch can did leak. My guess is that the first time they fueled it, during the launch campaign, is that they did it the same way that they did during wet dress rehearsal 4 to verify that it in fact does leak if you try to fuel it that way. And then the NASA public affairs officer, Daryl, that's the guy that looks like Clark Kent, he said that they tried a manual filling mode and that fixed the problem. They changed something so that whatever that manual filling mode was their fix. That's my guess. Can't prove that. I'd have to ask. Can't prove that.
Discovery, go at throttle.
My guess is that that was the test. They did it to verify that it was doing the same thing that it did during the last wet dress rehearsal, and then they implemented the fix, and it did fix it. Just a guess, though. Public servant, 50 freaking months. A lot of shoulder arching and hootie in the blowfish months. Yep. While it was going on, they stated as much. Yep. So this is a little bit of a complex case since the teams have not had opportunities to practice with the SLS system except through the green run tests. A different setup where I'm sure they learned more about how they wanted to conduct operations. So the change I think can be expected, but I still want to know when this change occurred. Right after the green run or last week? Yep. Like, was this practiced on the wet dress rehearsal? Rocket Guy, my guess is no. They never got that far. They never got to engine bleed during the wet dress rehearsal because they kept having problems with that catch can. The manual filling was to warm it up by stopping flow and slowly introduce flowing again around to chill both sides of the interface. That allowed the seal to reseat. Bingo. Okay. Yeah, so here's the thing, fellas. They won't know if it's a bad sensor. They won't know. They won't know until they try it again. They don't know if it's a bad sensor. The ground sensors said it was working right, but the flight sensors didn't. Now, that could just be that they didn't get the same kind of plumbing that they did because they changed the procedures, right? Your lighting looks different. I changed the lighting when I set up the new setup in my office, dude. I get the impression that they changed the bleed timing as they couldn't get the bleed test into the wet dress rehearsal. Maybe, Mappy, we can't prove it otherwise. Interesting. I'm trying to think what... There's a chance it rolls back to the VAB, right? They're going to try another launch attempt, but it's possible, yeah. There's a crane lifting sections of what looks like scaffolding onto the ML. Looks like an attempt to reach the sensor. Hard disagree, Alpha. I don't think so. If anything, that's to do what Charlie Blackwell-Thompson said. She said that they were going to retorque the bolts and check the seal on the catch can. That's most likely what that's for. Guys, there is a service gantry built into the pad system for SLS if they have to get at the main propulsion system. Here, you can see it on Google Earth. I'll show you. How's the new house? Will we get your OF? I don't know. Do you work for NASA? No, I don't. I'm just a very big space fan. This is my Graceland, sir. No. They said they'd have to enter the engine section to R&R the sensor. One does not simply enter the engine section. Yeah. So if we go look at 39B, it's sitting here. You can see it. Yeah, see it right there? That thing. See that? How that just, weirdly enough, has engine main propulsion section shaped cutouts in it? That whole cart slides over the flame trench, and then it can lift up. It's very similar to the Raptor inspection plate that SpaceX has for looking at the engines on Super Heavy. Remember the other day when Booster 7 like farted out the bottom, and they moved that gantry thing in there, and they were able to look at the engine section? They have something like that for SLS. That already exists. It's this thing right there. It's a cart that kind of goes over the whole thing. I'll check if I can find it on... Oh, no, not there. I'll check to see if I can find it. Images... Hey, Spearcraft. 63-month resub. Thank you. You should be able to see it in this picture. Nope. Nope. Where are ya? Where are ya? That was from the flow test. Oh, there's a picture of Bill. There it is. Actually, that might not be it. Oh yeah, no, there it is. There's your service gantry, right there. See? Yeah. It's on little train wheels. And they can get this thing up under SLS, and then look, see all the hydraulic risers? They can get up at that. They can get up at the main propulsion section, or main propulsion system. So I think that gantry that they're putting on 39B is to just retorque the bolts on the catch can. Pretty dang sure. It's that thing right there. See that thing? That's the service gantry. So, fellas, I got my tickets at Jetty Park for Saturday. Nice, Andrew. I believe that's the platforms that the engine service platforms sit on for launch. You can see them sitting down the hill in some pictures. Yeah. Point is that they can get at the engines. You just gotta, you just gotta take the covers off. Well, there's your problem. No, you might have to take some things apart to get at said sensor, but guys, who do you think is going to get to the moon first? I can't decide and flip-flop between NASA or SpaceX. Jake, I don't usually like to answer a question with a question. Can I ask you a question, man? If you don't mind. I get asked that a lot. I get asked, who do you think is going to get to the moon first, NASA or SpaceX? Jake, my question back to you is, where did you hear that they were competing against each other? Like, did you hear that from a news article or something? Did you hear that from something on Reddit or something, or like on Twitter or whatever? Or like, where was that information presented to you that they were competing with each other? Because they're not. That's the thing. SpaceX is building NASA's lander to go back to the moon. So it's kind of a joint effort, if you really wanted the answer. Jake, the thing is that I get asked that question a lot. I'm trying to figure out somebody is out there putting out bad information, putting out information that's false, or if it's just like what people say on Reddit or Twitter or whatever, or like a YouTube clickbait thumbnail. Oh, there you go, goalie. Yeah, it's a little rezzed out. I mean, aren't they going to get at the same time on the Artemis mission? Yeah, that's. I don't mean to put you on the spot, dude. They wouldn't be able to just stick some extra temp sensors in the Soyuz igniter style, in their Soyuz igniter style, would they? Valid point. I mean more which rocket is going to be completed first is really what I was asking. Well, SLS is ready to go on the pad, dude. I would say that unless Starship gets stacked in the next couple of days, I'm pretty sure NASA's going to go there first, man. Okay, that makes more sense. If that's the question you're asking, what do you think is going to go first, SLS or Starship? I think SLS is going to go first. You can see it here on the right. Did John take a picture of it? So this is from John Krause. Yeah, there it is. See it right there? Great picture. There's also the funnel over there. Yeah. How was the presser? It was good. Yeah, Remo's good. So long story short, guys, is that NASA isn't sure if it's a sensor or not. You can't be absolutely sure. Do we want to go and sit there and take that engine apart? Moreover, do you want to do it on the pad? The sensor might not even be the problem. It could have been your fueling procedures. It's possible. That's why NASA was giving such kind of non-answers there. You know what I mean? Because it would seem that the sensor on engine 3 is giving anomalous data. So it's not giving good data. But also, you can't rule out, you don't know for sure. If NASA had done the exact same procedure to fuel the rocket and bleed the engines that they did during the green run, and then got a bad temperature reading, then I would say it's the sensor. But if this was me, and I'm talking this, so like this is me now, if I saw a differential temperature reading from a ground side and a rocket side sensor, temperature sensors for the same system, so basically the temperature on the pipes or your monitoring system from the ground is reading a different temperature than the flight instrumentation sensors that are, or the flight temperature sensors on the rocket, and you did a different fueling procedure, well, then I would say more it's the fueling procedure, right? Are these single sensors or are they redundant? Siegfried, well, a ground and a flight sensor is probably, that's good, that's double redundancy right there. But here's the thing, the flow rate sensors and the scavenging systems, John Honeycutt said this, they said they were getting bad temperature readings, right? But they said that the engines were bleeding straight hydrogen. So that means that even though they were getting a bad temperature reading, the bleed line vent was actually showing the correct flow rate, which that points towards a bad sensor. But see, here's the thing. Even if that's the case, this is why this gets so ridiculously complicated. Okay, even if that's the case, everything is pointing towards a bad sensor. What if your new fueling procedure broke that sensor? See what I mean? This stuff is way more complicated than people think it is. What if they broke the sensor with that different fueling procedure? You wouldn't know. You've never tried that fueling procedure before, which is why I go back to it. Like, I'm not trying to second guess NASA. I respect the work that they do. I would really, really be curious as to why your fueling procedure was changed from your ground test to your flight test. And it'd be, how long, and this is Rocket Guy's question, how long ago was that decided? How was Jeddah? Okay. I got Kevin into the points-ish. Australia was terrible. Yeah, terrible. Just send a guy to stick his tongue onto the engine bell. Yeah, there you go, Goal. You got a picture of it? And kind of. Why change something if it's not broken? Well, High Vise, that's the question that I would ask. But they did say that they changed the fueling procedure because they don't have as big of a hydrogen. Long story short, they don't have as big of a gas station on the pad as they did on the test stand. There it is. There it is. Commodities. They said that they wanted to preserve commodities. So that tells me that the hydrogen tank at 39B is not as big as the tank on the B2 test stand, which also brings up another point. Why would you use different fuel tanks? Yeah, high-vis, exactly. Why would you do that? Why would you use different fuel tanks? The answer to that question is that it probably doesn't make a difference. But do we know that for sure? That's my question. Repeated testing but single launch? Perhaps, Aqualex, yeah. Because there's two types of fuel? Yeah, Scooby, but they were testing the same core stage. They were testing the core stage at Stennis during the green run on the B2 test stand, and they were testing it, well, they were trying to launch it here at 39B the other day. Why would you change those? Yeah, I've seen it already. God, believe it or not, Bandit linked it to me last night, or this morning, or something. So, it's very interesting, is it not? Like, I would be curious why and when they changed the procedures. What's your prediction for the third, then? What's my prediction for the third? To save costs, Josh, it's possible. Sig, I don't know. Everything's contingent on trying to bleed the... Everything's contingent on trying to bleed the engines. If they bleed during replenishment and it works, then it wasn't a bad sensor, was it? How much different is the external tank to the SLS core? People think that there's a ground tank issue. How much different is the external tank to the SLS core? People think that it's a ground tank issue. The external tank and SLS cores aren't ground tanks, Goalie. I don't understand what you're trying to ask. Yeah, I think they just threw themselves down a rabbit hole of sorts with that because you now have to check boxes you haven't had to check before. It's a new vehicle. It's a new vehicle, dude. If they have to delay due to weather, how long must the hold be based on fueling? If they have to delay due to weather. Well, there was an hour hold on fueling for the first launch attempt to WD-40, and it didn't affect the main countdown, so... That's what planned holds are for, dudes. Everybody's like, why didn't they do planned holds? Why don't they just do a timer? The planned holds are there for a reason. And it's there for that reason. In case something pops up, like a thunderstorm. Right? I think that's the question you're asking. Could it be that they used existing? Alright, I think I got everything in chat. What is a more powerful rocket between this Saturn V SLS Starship with the booster? Starship has the most liftoff thrust, Jake. Yeah, Starship has the most liftoff thrust. About double Saturn V and SLS. Maybe they wanted to add some sort of extra space to the side of the tank to allow robot repair from space in the future or allow ice to build up. Maybe they want to add some extra space to the side of the tank to allow... What? What? Wait. Again, what's the context of that? I'm confused. I'm keeping up with too many conversations. speaking of, there's a thunderstorm here and there's water coming in the window. Why am I typing this? Spraz, I don't know. Go close the window. Yeah, so like if Falcon 9 holds due to weather after fueling, there is a set time for a recycle. WD-40 depends on conditions. If weather is going to play, I would say they'd have to fuel the vehicle. So like, okay, say the T0 time comes up, right? Or you're like maybe an hour out from your potential launch time and a rainstorm pops up, they can hold the vehicle with full fuel. They can stay in replenish mode pretty much indefinitely until the tank runs out, until the gas tank runs out of hydrogen. I say gas tank like the tanks on the pad, the ground service tank, ground service equipment tank. My prediction: if they can confirm liquid hydrogen coming out of the engine and be certain about that, then they'll call the engine temp sensor bad. Whether they roll back to swap it depends on its importance during flight, I think. A bleed sensor, Aqualex? Yeah. If it was the shuttle, I think they would roll back, but it's SLS, so. But then again, at the same time, at the exact same time, you want good baseline data for your first flight. The conditions need to be as ideal as possible. According to Honeycutt, it's a developmental flight instrumentation sensor and it's not used for operational flight. And see, Novus, I missed that part. It's a DFI sensor. Interesting. Do you think methane helps avoid many issues in plumbing compared to hydrogen? It does, Foz, but you're going to sack performance for it. That was during the conference at some point. I think I missed that part, Novus, because I was, yeah, I missed the part. John Honeycutt's great, dude. Every time he's in a press conference, the guy drops knowledge bombs, dude. Novus, what would you do? I don't know. I mean, you can't prove conclusively whether it's the sensor or not. You can't prove that it was the fueling system. You're going to have to test again. John Honeycutt's a shuttle guy. Tech, yeah. Mm-hmm. And race car analogies. God, do I like that guy. That guy's the best. Got to get it up to the right temperature. Or in SLS's case, down to the right temperature. I trust the experts on those sisters. Cop-out answer. Ah. How you doing, EJ? Felt a little bit sad because of the delay, but hope Friday will be good for launch. Yeah, Dread, we'll find out. I'll be able to tell you when they do that engine bleed. Someone took the picture at last. Yeah, the reason why methane doesn't leak like hydrogen does is because methane has that huge carbon atom attached to it. Yeah, it's 4 hydrogen and 1 carbon. It's 4 hydrogen kind of attached to a carbon molecule. That carbon keeps everything nice and stable. Is it hot in your office? Looks like you're sweating. Yeah, Naroku, I can't catch a break. If I turn the fan up, people complain that there's fan noise. If I turn the fan down, people ask, oh, is it hot in there? I'm like, yes, it's hot in here. Yeah. Do you think the pressure is high to try again without further testing in 3 days? Well, do you think the pressure is high to try it again without further testing in 3 days? When's an opportune time to test, Sig? The most opportune time to test with SLS is during the countdown, unfortunately. Did I find out where those rubber parts came from during the last test flight? They did, Finn. Did they ever tell where they came from? I don't remember, honestly. You should give RTX Voice a try. It's a neural network-based noise filter. Yeah, Micon, the reason why we have so much fan noise is because I don't have an insulated ceiling in this building right now. I have to build it. The fan noise will go down once the insulated ceiling is good, because then I can seal this room up. It's okay. Temp's going down, guys. Temp's going down. I don't mind it. I'm listening to North Filters America. Yeah, I know. You guys don't understand. If I go mess with RTX voice and I screw something up, which is very likely because I have no idea what I'm doing with that particular thing, that means downtime for the stream. Okay, I figured it's about high time that I say this. People always say, "Oh, why don't you just do this?" Oh, okay, I'll go do that, and then I break my streaming setup, and that means a day of not streaming. Don't you think I've taken enough of those days over the past 3 weeks? See what I mean? It's not just as simple as, oh, let's just change this. Oh, let's just change this. I could change something and it could break my setup completely. And then I have to do it now, so that I have to go back and I have to fix things, or I have to sit there and try to power through it until it works. It is very, ask any streamer, it is very easy to get stuck in a loop. Oh, well, I gotta sit here and fix this. That could take days. I'm not saying it would with RTX voice, but it could. That's downtime from the stream. I don't get paid time off. Understand? See what I mean? This is my money maker right here. This thing working is contingent on me eating. I can't. Oh, just change this, CJ. Just change this. Streamer man, have you just tried this? That's why I get annoyed when people just suggesting things. Like, don't get me wrong. I know you guys are just trying to help. I get it. I understand. But, you know, I figure that after a decade of doing this, that people would give me a little benefit of the doubt and just say, oh, maybe he just moved into a new setup and, he hasn't gotten everything ironed out yet. But, once again, that's not... People won't know that until I say that. You know what I mean? So, if you guys wonder why I get annoyed, like, not annoyed... If you guys wonder why I'm like, no, I don't want to use RTX voice. No, I don't want to do this. No, I don't want to do that. Because I don't want to screw with my setup. I don't want to screw with my setup. That's all. On OBS, put 2 filters on the mic. Noise suppressor. It takes 2 seconds.
Discovery, go and throttle up.
Higher. Thanks. I appreciate the disrespect. Thank you. Eukerman for insulation. Nice. Change your wallpaper? What are you, crazy? It's alright. It's okay. I will find a solution. Going to run it like Stennis, same issue happened. You think so, Joker? Yeah. Oh, I didn't mean it like that. I wasn't being sarcastic or whatever. Yeah, I got you, man. It's all good. We're all good. We're all good. It's fine. Yeah, it's fine. Guys, long story short, I don't have a ceiling, and I have to crank the fan in order to get this room to cool down, because metal roof. If the sun's beating on that metal roof and I have no insulation layer below it, the heat's just going to come right into the room. And that metal plate, with the sun beating against it, more heat coming against one side is just going to convect heat down. I know. You know how hot that the roof needs to get for it to convect heat down? You could probably cook an egg on the roof of this garage right now. Liquid cooled roof. So the way to do that is to put a thermal insulator between your roof and the setup, which is the drop ceiling. I'm not just putting the drop ceiling in. That's not good enough. Okay? I'm not just putting the drop ceiling in. I'm putting roof insulation over on top of the drop ceiling once I get it hung. The reason why I'm doing that is because you want to make a plenum. This is why attics, for instance, have a soffit in it. So, like, you have vents at the top of a roof, and then you have vents underneath the sill of a roof on a house, because you want to make... the roof is going to convect heat downward because it's going to be saturated with heat on one side. That heat has to go somewhere. It's going to go down. It's going to go down into your attic. You ever notice the attic in your house, if you have one, is really freaking hot comparatively to inside? Couple that with all the heat in the house rising, right? Unless you're insulated, right? So if you make a plenum up there, basically the attic, that air inside of the attic gets, the heat will heat up the air inside of the attic and it'll just vent out the top. And then the soffits will pull in more cold air. I got to give that heat a place to go. I have to give it a vent. If I don't give it a vent, right, you have to give it a plenum up there. There has to be an open air kind of reservoir between the top of the roof and the ceiling. If there isn't, that heat will just keep coming in, and it'll just keep coming in, and my air conditioner has to work twice as hard. What I'm telling you is that once I get the drop ceiling in, the air conditioner is not going to need to work as hard to cool this room, and there won't be as much fan noise. I just haven't gotten time to put it in yet. It's halfway put in. Or we could just wait until the fall and then it's not a problem at all. Will you be using acoustic ceiling panels? The drop ceiling panels actually are pretty good sound deadening to begin with. Then you need a wood stove. Yep. Do you have an updated walkthrough of the office after the painting? It should be on Discord, Naroku, yeah. And he plans to install a roof fan once the drop ceiling is in. I just have vents in the roof. I have vents up there. But yeah, that's the thermodynamics of my office there. But anyway, going back to SLS dudes, yeah, they gotta... Yeah, I counted, right? Yeah, see the vents? There's vents right there. Actually, that's air conditioning. You know why? You know how I know? AC vents are up there in HVAC. Heater vents are down here. Anybody know why? Why are heater vents on the floor? Why is air conditioning in the ceiling? Heat rises. Done. There you go. Jade, hey Jade, just popping in to shed some light on the 39B commodity situation. The new LH2 sphere comes online with Artemis 2. It's mostly done now, but not quite. So they currently have to do all sorts of chicanery to the recycled pad, recycle the pad like siphoning from Slick 37 and calling a bunch of LH2 tankers. Jade, where'd you get that information from? Hey, Ray, thanks for the raid, buddy. You guys like scam bait streamers. Ray's a good dude. Modder Paul scam baits. Nice. Are you ever going to go back to MSC in the rally car? Yeah. Sometime. Hey, Cortland, what's going on? Ray, what's going on, dude? Give me a moment. Thank you. It's from an old Phil Sloss article. Oh, okay. Ugh. And I know from program people that it's still done that way. Hey, what's up, Scam Baits Raiders? What's going on, guys? How many scammers did Ray get today? If they roll back, can they fill in the cracks, or are they there till she takes the big plunge? Fill in the cracks of what? In the inner tank? See, I missed Chris G's question. I know he asked about that, but I didn't get the response. Jade probably isn't wrong. They can't recycle the fuel in the oxidizer. I was a little surprised when I heard that. The second involves 10 to 12 trailers offloading their contents at pad 39B before being routed approximately 5 miles to Cape Canaveral Space Force Station Launch Complex 37B to be filled from that pad's LH2 storage tank before being routed back to 39B for offload. Can we get a summary of your stream? Sure, Ratrocks. I'm a STEM streamer, a STEM outreach streamer, particularly focusing on like space flight. I teach people about rockets. We're talking about SLS. NASA had a huge launch attempt on Monday and they scrubbed. I'm trying to figure out why right now, at least. Yeah. Just any foam crack. Yeah, you're good. They would have to roll back. It really depends on the severity, Goalie. I don't think they need to worry about it like coming off and hitting a space shuttle, for instance. So it's probably not as big of a risk as it is during with the shuttle, but I'm not sure. Ray worked over a couple scammers today. More to come. Nice. Are they still on for Friday? They moved it to Saturday, Scam Buster. Apparently Saturday was always on the table. NASA just didn't say that. Yeah, so Saturday at 2 p.m. Off topic, but did you see about the USS Texas? I know it's leaking, Jason, but that's all I know. It's very unlikely that they repaired the TPS cracks on the pad. Okay, yeah, Novus, that's what I thought. I guess it really depends on the severity of it, but no, they have... I mean, Novus, they don't have Saturn V mobile service structure. They don't have one of these bad boys. They don't have one of those bad boys. That would make it pretty hard to do. Just put some RTV. Yeah, foam is a lot less critical than the shuttle days. Yep. So, look, hang on. Let me look at these Google Earth pictures. I need to see something. Yeah. Okay. So they're testing a rocket with a fuel tank with the shuttle's fuel tanks, the shuttle's ground side fuel tanks. Because the actual hydrogen fuel tank that's going to be needed for this rocket is not finished. Also, cracks themselves aren't necessarily bad. It's about the probability of a blow-off, TPS debris from cryopumping that you got to worry about. Okay. Okay, Novus, good to know. So, the old 39B sphere is still Saturn size, so that's... So basically it can do a launch as in one. That's why they didn't want to bleed it. That's why they didn't want to bleed during topping. Or not topping, during fast fill. That's why they're bringing a second tank online to improve the scrub turnaround time. Rev, my question, I okay. I got to think about this one for a second. So, all right, forgive me for being a little candid here, dude. You know I love this thing. You know I love what I love, dude. I'm a very vocal advocate for SLS and Starship and everything, right? Why? Okay. Why would they change the fueling procedure if they were worried about turnaround? Okay, they would change the fueling procedure because they're worried about turnaround times, right? That's the idea. They changed the fueling procedure because of commodities on the pad because they don't have a big enough fuel tank to be able to recycle SLS. I get that. I understand. The new fuel tank will be online soon, so you won't need to worry about that. So why in the name of Jeb are we changing the fueling procedure for a configuration, for a pad configuration that's not going to be there next time? Why would we do that? That's the question. Like, why would you do that? Why would you, what? Am I like, dude, who thought this was a good idea? Why change the fueling procedure for, like, it's an honest question. Like, I don't understand. That's a good question, but I don't really have an answer. I don't work that far up. No, I get it. I'm not looking for answers from you. I'm trying to think. Why would you do that? Because I have to give NASA the benefit of the doubt. I know they're not that stupid. They would not do that unless there was a very, 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 very good reason. Right? I have to give them the benefit of the doubt. There are people that work at NASA that are way freaking smarter than me. Okay? So why would they do that? Let's try to talk it through. Why would you do it? Why would you do that? It's the Artemis 1 delays that meant it'll be done during Block 1. You mean changing the fueling procedure during the countdown? No. Novus, I'm talking about changing the fueling and bleed procedures over from Stennis to Pad 39. Apparently, they did that because they're worried about commodities, which is what Charlie said in the press conference just a second ago. Okay, I understand you're worried about commodities, but the only reason they're worried about commodities is because they're using Apollo-era fuel tanks, and SLS has a gigantic hydrogen tank, frankly the biggest that NASA's ever used. It's one of the biggest rockets they've ever made, right? Like, we know that. So they were worried about recycling? So my question is, why would you put SLS into a fueling configuration for the first test flight that you're never going to use again, because you won't have to worry about commodities once the second hydrogen tank comes online? That's the question. Why would you do that? Why would you that? I'm not trying to be critical. I'm not trying to be a dick. I'm actually wondering, why would you do that? Maybe is there a pressure to launch here? So just to clarify, the new sphere was originally supposed to be done just in time for Block 1B. Artemis 1 slipped, but it didn't. So when these procedures were drawn up, it might have been for all 3 Block 1 flights, or depending on the exact age, all 1 of them. Because if the procedure worked for a smaller storage, it would give ample wiggle room for when the new tank comes online. Hell, Hydra, that's the best one. That's the best. They probably did it so they could quickly recycle if they needed to, and now they need to. But they need to quickly recycle because their fuel. Well, see, potentially, that's the thing. It's potentially the problem. We don't know. It could still be a bad sensor. The fueling procedure could have had nothing to do with engine 3 not showing the right temperatures, right? I personally, my gut's telling me that it's the fueling procedure. Because engine 3 did bleed. It bled, but it wasn't showing the right temperature. But then again, why would the fueling procedure screw with the sensor? I don't know. I don't have that answer. I'm not that smart. What's the difference between Artemis and the SpaceX rocket that's being built? Opie, they're exactly the same in every way, shape, and form. Except all of them. It's a completely different rocket, dude. It's a completely different rocket. SpaceX is building a big enough rocket to move the lander out to the moon for NASA. Yeah. I personally think that's a good idea. Having two big rockets instead of one is usually better, because if something goes wrong with one, you can use the other, and vice versa. You think there's a ton of pressure? Yep. What's the difference between Artemis and the SpaceX rocket? Okay, I already answered that. Charlie made it sound like they still think they could do a 48-hour turnaround if weather scrubs for the second attempt too, so it might not be as big of a constraint as they thought. Yeah, Jade, that's the other thing. This is a test flight, so you won't know until you try it. I don't know, man. I can't. I don't want to second guess NASA because I don't know. I don't know. I'm just some guy that streams on Twitch, and I understand it's very easy for me to be critical when I'm not in the hot seat. I get it. I get that. I really don't like it when people disrespect NASA like that. It really pisses me off. Which is why I'm like, when I say I don't understand, I mean that. I don't mean I don't understand why you're doing it this way because that way is dumb. I don't understand why you'd think that's okay. Well, if parts are made by the lowest bidder, it could be a crap sensor. Yeah, Rebel, that's possible. I mean, but the other three sensors worked fine, you know? Yeah, Foz, maybe. It's possible, Dot. Yeah, I wouldn't rule that out. But at the same time, I know there's people... Yeah, I mean, I don't know if that's the motivation for it, but yeah, who knows? Well, the fueling procedure was changed to fix the leak on the QD seal, so this might be them just seeing if it works for this, since they can only test during this configuration. Why you aren't a program director there is slightly beyond me. I'm not... On paper, I don't know anything about rockets, Celtic. On paper. Hey, guys, that's the thing. Lowest bidder doesn't necessarily mean it's a piece of junk, you know? It means somebody freaking bid on something, and it could be a high-quality part. Maybe they just wanted the contract. Happens all the time. Those are great pictures, goalie. Mike, what's up? I have a hard time thinking the Orion capsule is efficient enough to travel to Mars. A capsule that long a distance in time need a larger vehicle. Looking forward to know. The Orion was always meant to attach to a larger vehicle and then go to Mars, dude. Yeah, no, Orion ain't getting there by itself. No way. I think it's about cost versus benefit. To fix this issue at Green Run, they closed all the bleed valves, increased pressure, and left that particular one open to make at GR. Okay. To make the bleed happen. The cost of going for bleed is that a possibility of not nominal conditions considering the LH2 vent umbilical. They were balancing in that countdown. There was too much risk. The benefit is that you get further in the countdown. At least that's what they said in that other presser after the scrub. Novus, define GR just to make sure I'm on the same page, if you will. Rebel, I would say that lowest bidder stuff is more a systems engineering problem than anything. It's not the lowest bidder's fault you bought their junk. Green Run. That was an issue that cropped up in the Green Run. Let me read again. To fix this issue at the Green Run, they closed all the bleed valves, increased the pressure, and left that particular one open to make the bleed happen. The cost of going for bleed is that a possibility of not nominal conditions considering the LH2 vent umbilical leak. They were balancing in that condition. They were balancing in that countdown. There was too much risk. The benefit is you get further in the countdown. At least that's what they... They also resized the bleed lines for SLS after that. Don't know if that worked out the way they had hoped. Yeah, Celtic, I wish that was true with the space program. If that was true, I'd be running NASA, you know what I'm saying? No, not... That was a little overzealous on my part, but yeah, I know, I get the gist of what you're saying.
Go and throttle up.
I'm sorry, using my voice to text this evening, and it's not like quenching my words correctly. I apologize for shoddy quality control. Ah, Rebel, it's okay. I understand what you're getting at. Hey, Torlab, 61-month resub. Thank you. Have they said how many SLS fills the pad can do? I think 4. I think is what Charlie said. Yeah. Torlab the Mighty, 61 months. Thanks, buddy. Planning on still going back to university for engineering, or is buying a house scrub those plans for a little bit? Buying a house scrub those plans for a little bit. I dipped into my savings a little bit. By a little bit, I mean a lot. But I really wanted this house. The idea was that we bought this house, and with this new setup and everything, I'll be able to give you better content and stuff, so we can make that money right back. I hope that. I'm banking on that being true. If it's not, I got a little bit of a problem, huh? Are you still going to do after hours? Yeah, maybe. Plus, a cost of going for it is you don't have the commodities for an opportunity on the 2nd and the 5th. That was the plan at the time, and something Charlie had to consider. Yep. Didn't that student loan debt clear news help? I don't have any state student loans, Foz. I already paid them off. I paid them off years ago. It's just private loans left over now. I don't think I ever told you guys that. You guys, yeah, no, I paid those off. I paid off all my federal loans a long time ago. Boy, I really wish I had been a little bit more lazy on that one. That would have been useful. Yeah, that didn't do anything for me, guys. Yeah. Celtic, what do you do? I'd clear you a $2 billion budget a year if I had one. Yeah, cockroaches. Yeah, I'm aware of that. But Primo qualifies for it, which is pretty sweet. So, if Primo qualifies for it, that pretty much means that I do too. So, it's not all bad, dude. But also, we kind of pushed on that deal. Yeah, I don't want to talk about that one anymore, dudes. Yeah, it is what it is. It's not where I stand on that. As somebody that does education inadvertently, is this problem shouldn't have happened in the first place, but it's okay. That's a touchy issue with folks, and I don't really want to talk about it. We could talk about rockets, though. So I have a question for you. I know the answer already, but I want your thoughts on it. If NASA came to you and said, hey, AJ, we want you to be the first test pilot for SLS, what would you think it'd say? I'd do it, Shadow Man. Yeah, absolutely. Yeah, sure. I would, yeah, I'd do it. Why not? I do computer security, actually. Cool. Right on, man. That's really cool, Celtic. Yeah. My question is, why go from a reliable rocket with working parts that have been tested to a rocket that's a few green runs and has thus far proven to be kind of unreliable? I mean, Firework, the shuttle had been going for 30 years. Once SLS goes for that long, it'll be just as reliable. The remaining question to me is whether they could recycle for the 5th or 6th if it's just weather. That sounds like they could, but I'm kind of hoping for the 5th. The 6th window is only 90 minutes, yeah. When do you reckon they'll announce Artemis 2 onward cruise? Probably sometime after this launch. I know for a fact you wouldn't want to be on Artemis 1 for one simple reason: there's no life support. Yeah, we were playing off the notion in that particular question, Thomas, that if it did. We might have friends reverting to previous statement. Cool. Oh, yeah? That's neat, Celtic. Alright. Yeah, well. Yeah. Celtic, I'll be honest with you. If I was managing a project, I wouldn't be afraid to be a dick to people. People would not like me. I already know that people wouldn't like me. If I was running the space program, people would not like me. Like, I would get questions from reporters, and I'd be like, that's a dumb question. I'm not gonna lie, I'd probably end up doing what Elon did that one time. That's a stupid question. Next question. I'm not gonna lie, I probably would. Dude, you don't have time for bull crap with this kind of stuff, you know? Like, if I was, like, dude, I'd be focused on the project, not the project. I don't care if someone asks a question that's not pertaining to the press conference. I don't care. Like, I don't know. Ask somebody who knows. It'd be somewhere between, like, Bill Belichick and the, what's the name of the basketball coach that took no crap from reporters? I forget his name. More likely no one would let you do PR. Yeah, most likely. Yeah, there you go. Mike Tyson. Mike Tyson's the best. I think it's Bobby Knight throwing the chair. You got a problem with it? Turn off your station. Like, dude, I don't have time for that. Like, basically a subcontractor that is basically a subcontractor is I've been working in federal space for 15 years. That's exactly what that space needs. That's always been my thing, Celtic. NASA. I understand it's NASA, and you know there's a certain bit of, you know, like professionalism that's oriented with that, but also at the same time, guys, go watch interviews with Gene Kranz. Gene Kranz wasn't afraid to tell reporters to shut up. He did it a bunch of times during SDS1 when they kept asking about the damn tiles. Go watch it. Go watch the interviews. He wasn't afraid to be like, that's a dumb question. Next question. Popovich, that's the guy. That's the guy. Playoffs? Roadrunners talking about winning just one game. Playoffs? Dick Vermeil. Good times. You'd be Marshawn Lynch. No, I would answer questions. Sure. I'd answer questions that are pertaining to what the press interview is about. And I'm pretty good at answering questions, like...
Tranquility Base here. The Eagle has landed.
I know what you mean, Celtic. Yeah. And yeah, I remember that interview with Gene. He was the tops. I thought that was Dick Vermeil with a... could be wrong. Still funny, though. Yeah, I try not to be a jerk about it, Penta, because everybody that comes in here and asks a question like that is they're just trying to learn. The press, like we saw it just a second ago, certain journalists are looking for a narrative, and I don't like that. That pisses me off. That means you got an axe to grind, so that means you're impartial. That means you're not impartial. It means you're a dick. That's why I got so annoyed when Eric asked his question, because he just wants to go right in the press. Oh, this is just another wet dress rehearsal. This is just another wet dress rehearsal. NASA doesn't have their shit together. Like, dude, fuck you. Wait, that's such a disrespectful thing to frigging say. And I'll take the timeout. I swore, I'll take my timeout. I'll sit here for 10 seconds. That's fine. It's such a disrespectful thing to say. It shows that lack of impartiality, and that's really obnoxious. I really don't like that. I hope so, Foz. That'd be nice. Oh God, the drop tanks make it look terrible. What is this? What's that a picture of? Oh. No. No. Yeah. No, you're right. It's rocket science. Rocket science is tough. Yeah, no. I'm just going to sit here and pretend like I know better, and I'm going to try to get you to say something to enforce the fact that I think I know better. To try and reinforce the fact that I think I know better. It's bull crap. It's bullcrap. That question pissed me off. I legitimately got a little annoyed. Yeah, Rev, that's what I mean. He's just using it as fodder to say bad things about SLS. And don't get me wrong, you can say whatever he wants, dude. And And he can say whatever he wants, but I'm not going to say he's not a douchebag for freaking saying it. You can ask any question you want. I don't care. It doesn't bother me. Not saying you shouldn't say this stuff. I'm just saying, when you say something that's blatantly wrong, I'm not gonna not say you're wrong. Your cam is hiding the credits. Oh, you want to see the TikTok thing? There you go. Oh. Yeah, they look a little strange with the drop tanks, I'll say. Oh, but also F-22. I mean, Jason, if I'm looking at those right, those are F-15 drop tanks. They probably have the same hold down point. Yeah, that's an F-15 drop tank all day. Wouldn't that ruin the stealth aspect? Well, Panta, yeah, but you really don't carry drop tanks in the combat zone. Two things. Those F-22s probably have those drop tanks because they're moving to a different base. If I had to guess. They're moving to a different base and they don't want to have to land anywhere. So they're probably carrying those drop tanks because they're being transported. The best way to transport an airplane somewhere is to, well, just fly it. And if I could be wrong, but if we sit here and think about this from a logical standpoint, the F-22 is the most advanced fighter ever designed, ever. I wouldn't just go and land that thing anywhere where anybody can just go take a peep at it, you know what I mean? I would have bases that are cleared to accommodate that type of vehicle where prying eyes wouldn't be able to see it on the ground, you know, like when they're working on it. I wouldn't I wouldn't want that. So, I mean, if that was me, which explains the drop tanks. I wouldn't want that. You know?
Discovery, go at throttle up.
So I would have the planes be they're being transported. Clearly, they're going somewhere. Here's to the new house. Congratulations. I hope all is well. Oh God, I didn't need to see that, T-Man. Yeah, maybe Gaw. I mean, you could probably let me take a look. Why would someone post this on TikTok? Okay. I really hope that footage wasn't like filmed yesterday or something, because, yeah. OPSEC. I didn't know they had bolt-on spots there on the wings. Of course, they can carry a full external payload complement goalie if they need to. Yeah. Yeah. And like I said, those are F-15 drop tanks all day. Yeah, that's an F-15. That's an F-15 weapons pylon. It looks exactly like it. Quick question: did you see the last tip? The last dono? There was a dono. Did I miss it? Oh, Torlav, add this to the new university fund. I'm sorry, man. I'm on a roll right now. Thank you so much. Sorry, I don't know if you guys noticed. I'm very passionate about this stuff and kind of take it super seriously at times, and it really bothers me when people don't do that. I know that it's kind of an elitist thing to say. It's kind of a dick thing to say, but it's true. I'm not gonna lie to you, you know. Torlap, thank you very much, dude. I really appreciate it. That question did piss me off, though. I'm not gonna lie. That really made me mad. Drop tanks are used for a ton of reasons. They can be used for keeping on station. They can be used for long-range stationing. The big thing is that they aren't bleeding primary fuel. They can blow those tanks at any moment and go full combat anytime they need to. Biggest call ever made. Cap drop tanks pushing you to clear. Yeah, with the F-15s. Those F-15s are out of Otis. I live near Otis. I like when reporters disrespect NASA. I don't, Blue. It's really annoying. Yeah, I don't. I get it. Stick it to the man, dude. I get it. Believe me, I understand. But, yeah. Yeah, Ernak, it's just the disrespect. It's the disrespect. It's so damn disrespectful. Way to insult those people's craft, like Honeycutt and Charlie Blackwell Thompson and Mike Serafil. Way to insult what they do. Good job. Tone deaf piece of shit. Oh, sorry. I'll take another timeout. Yeah, guys, go back and watch the presser if you want to understand what I'm talking about. Too long didn't watch. Okay. The short story is that he said, would you call this just another wet dress rehearsal? And the implication there is that, you don't have your shit together. That's the implication. It really, 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 really was a messed up thing to ask. It was basically, do you really know what you're doing? Would you say that this was just another test because you have no idea what's going on? It's really a disrespectful thing to do.
Discovery, go at throttle up.
The best part is he's asking that at the Saturday launch. Yeah, Buck. The reason why it annoys me is because he's already written an article. That's like I don't know, 5,000 words or 5,000 words of verbal dribble about the launch attempt on Monday, saying it was basically another wet dress rehearsal. So that tells me there's preconceived notions there, which means you're just looking for a narrative, which means you have no idea what you're talking about. Straightforward enough. Am I wrong? Yeah, Rev, I'm with you. You'd have to be knowledgeable to ask a hard-hitting question, though. Yeah, it's really disrespectful. Like, the disrespect is what bothers me. You don't know better. You don't. I don't know better. Yeah, Rocket Guy, that one pushed my buttons a little bit. It's just so disrespectful. It's such a disrespectful thing to say. It's gross, and it's embarrassing. Yeah, he actually phrased it worse. Something like, was that intended to be a wet dress rehearsal? Although, dude, what a clown. Like, forgive me for swearing so much. I don't usually curse this much on stream during the day. It's just... Oh. Scroat, 13-month resub. Thank you very much. No, Rocket Guy, he knows. He knows that. Yes, so they were. In fact, AF1 was pushing so hard they bled those tanks and were having issues keeping up. The pilot whom I've spoken to in person and about to retrofit that plane after that day. I like you actually know the engineering behind what you do. You're good. Celtic, look, that's always been my thing, dude. It's always been my thing. I'm not a rocket scientist. I'm not an engineer, guys. But I love the stuff, and if I'm gonna talk about it, and if I'm going to teach it, I best be damn sure that I know what I'm saying. I owe that to the people that actually do the engineering. It is my duty as it's my duty. He said duty. Nice. It's my duty there to know that. Because I've been put in a position where I can report about it. Here, have some Bezos bits to help cover the extra cost of those swears. Thanks, man. I'm enjoying being in here this evening. My pop worked for Old Man McDonald during Mercury through Apollo 12. Space is kind of in your blood. Hate to run out on you already, but I got some stuff to take care of. Hey, Rebel, you do what you need to do. I'll be here when you get back. Give you a follow. Thanks, man. I appreciate that. Yeah, gum. That's true. I don't ever want it to happen, but there are days where I wish NASA would just fold. Yeah. No, I know. Speak of the devil in regards to tankers, by the way. This is Bill Harwood. Okay, what's Bill Harwood saying? See, the reason why I like Bill Harwood at CBS News so much is because he actually asks questions to learn something and then goes and reports what he learned. Almost like, you know, that's what you should be doing. I have it teed up, Corey, yeah. SLS Artemis won 5 out of 5. A fresh wave of tankers has been called in to top off the hydrogen storage tank at Pad 39B. The additional LH2 will permit one last launch try on Monday if the weather keeps SLS on the ground on Saturday. And all other systems are healthy. Yeah, okay. Alright, cool. I think we got our story straight regarding the launch attempt on Monday. Noted, Celtic. I wish you were down here for the launch. Yeah, but T-Man, if I'm down there, that's... I wouldn't be able to cover it in any useful capacity. I can't stream from Florida. Like, I mean, I could, don't get me wrong, like... Just go on Tim's stream. Oh, it would be an honor if you would have me. Have you covered other news? No, not yet, floating. On to Imola. Yeah, yeah. You would need hardline in the signal down here. Yeah, you cannot live view stream. You can't do it from the Cape. There's too many people on their phones tweeting about how they're at the Cape, and it destroys your bandwidth. You can't do it. DOS had this problem a long time ago. Fortunately, NSF has NASA hardline. They're on a NASA hardline, but I don't think I'm cool enough to be able to get one of those. You know what I mean? If I was, then I would literally pack up all this stuff, put it in the back of the Ford, and freaking drive down there, and then set up shop at the press site. But I don't think we can do that. Not yet, at least. Tim said he's paying a ton of money for just 50 megabit fiber. See, Tim's connection is remote control, and that's why he's paying a lot of money, because it's a fully remote setup. Yeah. That's how NSF and such had all those cameras. They were tapped into the engineering, the engineering media feed, Jade. Yeah, I got you. He's just enthusiastic for space on the ground about Steve Irwin for Crocs. Hey, don't put me in the same... I'm not even in the same category as Steve Irwin. That guy's a legend. Starlink can't handle that. Yeah. Tim had Starlink as a backup. But even then, if other people are using Starlink, you know... Did you see his video on building the van? Yeah, I was talking to him about it, Phil, for a little while. He was trying to... Timmy asked me if I knew about, like, the wiring in the vehicle. I'm like, yeah. The vehicle side of the wiring, not the studio side. No. No, I know the vehicle wiring. If something goes wrong with the vehicle, like if something goes wrong engine side, I could probably fix that, but not the studio parts, no. It's because it's cool, STX. It's good stuff. You better have good insurance. Yeah. That truck is sweet, though. You haven't bought a condo in Cocoa Beach? I wish. I mean, Foz, I wanted to cover it with you guys. We've been waiting for this launch, and I've been talking for this launch for a long time. If there was any way I could do what we do here in Florida, I would do it. And not spend an exorbitant amount of money, because the whole, house thing. Thanks, STX. I appreciate it. Viewer record, the viewer record for this stream is 6,500. It's when I was on the front page. Anyway, yeah, dudes. So, let's think about where we stand here with SLS. We'll put a bow on it and go from there. So, they're going to try again on Saturday. I don't know if they're going to reinstitute the old fueling procedure or do the same thing again. I didn't get that part. Oh, I'd do it Aqualux, sure, why not? That would be great. I did hug a rocket engine one time. I stand below it since it's much taller than me. I see what you did there. I think they were waiting on the data to be scrubbed for a final decision. Yeah, Novus. I think I think you're right. It's pending data, so if there's any way that they can prove with the telemetry that this was a bad sensor, we'll see. I think they're scrubbing through it right now. I'll be honest with you, Novus. This is just my gut feeling. My gut feeling is that it's not a sensor. I don't think it's a sensor. I think it's the fueling procedure. I really do. I mean, that damn catch can, they were trying to remedy from the green run to here with the dang catch can. They were trying to balance it. They were trying to balance the bleed to the catch can leaking, right? Like that's what you said. Am I understanding that correctly? And between that and the green run, right, they implemented changes that they thought were going to compensate for that problem, but it seems like the changes that they implemented to compensate for that problem have led to their own problems, right? Am I understanding that correctly? But here's the thing. We call them problems. They're not problems. They're just a better way to do it, and they need to test more. I think that's the gist of what Eric was trying to say. Like, that's what he's trying to get at. But I think, guys, the truth of the matter is that this happens with every freaking rocket. This happens with, dude, remember how many times Falcon 9 scrubbed when they were trying to figure out the densified propellants? Orbcomm 2 scrubbed like 4 times. It took a week to launch it. I would know. I was there. I honestly wouldn't give him the credit. Yeah, I'm with you on that one, Rocket Guy. I don't know. What would you guys do? Not quite. The intertank vent umbilical leak was very similar to the engine section umbilical leak. I don't think it was caused, per se. Was it only 4? It felt like it took so many attempts. I think it was 4, Rev. Yeah, for Orbcomm 2, the first time they started messing with those densified propellants, yeah. Yeah, it was 4 times. And that wasn't even a new launch vehicle. That was a pre-existing launch vehicle with a huge upgrade, right? Like, So it's basically pending data. It could either be a sensor, it could be the fueling procedure. It could be either one. If I had the data in front of me, you guys would be damn sure that I'd be combing through it to get you an answer. I'd do it myself. I'll do that freaking crap myself. I don't care. I'd find it. Maybe. Maybe not. It'd probably take me a lot longer than NASA because I'm just one guy. It was a factor that prevented the same solution that worked on the green run. They didn't want to up the tank pressure with a leak at the venting location. Not quite. The intertank vent umbilical leak was very similar to the engine section umbilical leak. I don't think it was the cause per se. Huh. Thanks, Spox. Thank you. I appreciate it, man. I'm just trying to get the story right, guys. It's also like NASA does not have a bunch of SLSs ready to go if this one fails. Yeah, there you go. That's another thing. Yeah, it's a balancing act. It's always a risk, especially with a new vehicle. Hey, Noswolf. Good morning, buddy. Interesting. Yeah, well, we'll see. They're gonna try to, pending the telemetry results, they'll try again on Saturday. ABL is debuting next month. I think that's a bow on it. You got to go through the data. They got to go through the rest of the data. Frankly, having this press conference today, I think they should have had a press conference when they were done with the data. But it is what it is. Let me get more links up here for the rest of the storm. We were supposed to have static fires today from Starship, but they pulled those. We got new pictures of 39A, which is pretty cool. The one about the SLS gantries I don't need to share. We already covered that with SLS stuff. Come on, mouse. Oh, yeah, I'm still getting used to a new mouse. My mouse finally died after like 8 years of use. I have a Razer Black Shark V1. Or not a Black Shark, a Death Adder V1. It finally croaked today. I couldn't believe it. Why don't they just make all the data open source? Surely the public could find the answer too. That'd be cool, Paul, but there's apparently... apparently there's some ITAR stuff with it. Oh, nice, goalie. Yeah, I'll throw that in. Superior SLS headline. NASA delays Artemis launch after rocket gets scared. Nice. Here, you guys want to see it? Here, I'll show you. You want to see how much use this freaking thing got? And I don't even know if it's stopped working. I'm not 100% sure, but check this out. Look at the mouse buttons. They're buffed. See how shiny they are? The mouse is not supposed to be shiny. Okay? That's what it's supposed to look like. See the difference? It's supposed to be matte. That one's shiny. Because I buffed the dang thing from using it too much. Look at the grip on the side. I buffed the texture right off of that thing. That's how long I've been using this. I'd have to test it some more. I'm not sure if it's broken or not. It did stop working though, like straight cold stop working. So maybe it was the driver or something. But I have another one. I always have a spare. Yeah. For a second I was really confused about I could just walk off to the left like that. Forgot about the new house. You know what, Admiral? The other day when I logged off from the stream, I did too. I shut the stream off. This was Friday stream when we first played F1 Manager. I logged off and I turned around and did this and instinctively pulled the green screen. Pulled the green screen from right to left and started walking that way. There's a wall right there. The door is over there. Yeah, definitely did that. Yeah. I went this way to look for my apartment bedroom door, which would be like right here. Straight up. Straight up, dude. Yeah. And several times, I'll tell you, I had a desk fan right here to my left. You ever see me do this, like move my arm over here like this? I'm reaching for it to turn it on, and you hear dee-dee-dee. I've reached for the fan like 4 or 5 times. Oh yeah, it's not here, it's in my bedroom. Yeah. Dude, I moved my computer setup once. First couple of times using my computer, when I went to get off my computer, I forgot where I was. Dude, that happened, Rev. That happened. That first time, I went and I opened it and I'm like, wait, where am I? Oh shoot, the door's over here. And then I walked into my garage. I'm like, damn, dude, I bought a garage. This is great, you know. You should put the shuttle back there again so things look right. The cutout's right there. It's in the garage. Yeah. Proud of my 87 keyboard out of my cold shivering hands. Yep. Dude, yeah, muscle memory. Yeah, it's weird. That's gone. That was only one day. So the first stream that I did from here last Thursday, I was so like, oh my gosh, this is a new place. This is so cool. But by Friday, I had settled in, and I'm like, huh? Yeah, it got weird. You need to put the jersey back up. Sure. Yeah. That needs to be done. I need to get the ceiling in first, Blue. That's like priority one. Maybe I should just stream that. That way maybe it'll get done. But I'm not... Yeah. Not the best at... I've never hung a drop ceiling before, so I started doing it, but yeah, it's a little bit difficult, to say the least. Anyway, let's get to the next bit of news. So this one's coming from Thomas Erbuchen. He's the head of NASA's Science Mission Directorate. He's definitely a great guy, yeah, head of the Mission Directorate, and he talks like Gunther Steiner, which is even better. All right, when I visit NASA Kennedy, I tour companies as well. This time I was excited to meet Pat Svatek, Relativity Space Cape Operations Director, as his team is getting ready for the first flight of their rocket that uses 3D printing in new and unique ways. There you go. There's LC-16 with it's got the load cell on the stage, which means they've been testing it. So from here on out, does SLS have priority if SpaceX needs to fire off one, will they let them go? Not sure, goalie. Home Improvement Show. Didn't Brimo say something about that? Yep. Rocky. Oh, hey, I worked on that. Really? Before I say snooze, could you explain this to the average European? Okay. That's cool, man. Very neat. Can I explain this to the average European? United States Consumer Product Safety Commission. Always wear a helmet when you're riding your ATV through the corn. Ted wasn't sure how he found himself in the presence of megacorn, but it sure was real, and Ted was glad he wore the proper gear. Goggles, long pants, long sleeve shirt, gloves, boots, and a helmet. It's corn. It's corn! It has the juice. They're memeing. It's corn is a TikTok meme. Yeah, they're memeing. They're memeing. The U.S. Consumer Product Safety Commission is memeing. Oh dear. Scroll down. It's all they do. It's all they do. Oh my goodness. Is this funny or not? I can't tell. Is this funny or not? Pineapples in cool. I can't tell if that's funny or not. This is fun. I can't tell if I'm laughing at it or laughing at the meme. I'm not sure, man. I can't tell. I don't. All right, that one made me laugh. Oh my god. Oh my goodness. It's what we call nanar in French. Something so bad it becomes funny because of how ridiculous it is. Dude, every post is a crap post. Every one of them is a crap. I admire the consistency. Okay. Yeah, I don't know. But what's that predominant? Oh God, no. No.
For me, I really like corn.
What do you like about corn?
It's corn. A big lump it knobs. It has the juice. I can't imagine a more beautiful thing. It's corn. I can tell you all about it. I mean, look at this thing. When I tried it with that old anything cheese. But the bad thing about corn is the grease. The corn break can restore your energy. You really appreciate that whole ball when you love something. If you anyone loves corn, if you come to me, I can tell you all about it. If I was surrounded by corn, I would eat all of it. Go big and strong. Look at this, take a lump with the knob. Spread butter on. Boil it and toast it with the grease. Batter spreads out the good taste. But the soft corn is disgusting. Anything cheese. It's corn. A big lump it knobs. It has the juice. I can't imagine a more beautiful thing. It's corn. I can tell you all about it.
Brimo has been walking around the house randomly saying, "It's corn. It has the juices," for like the past week, and now I know the source of this debauchery. I know the source of this debauchery. We must eliminate the source. We must nuke it from orbit. It's the only way to be sure. Has Iowa gone too far? To be fair, we've been talking about a salami lid. The salami lid doesn't fit, okay? Call Sack, get the bombers on the horn. We're going to DEFCON 5. We must bomb the corn. But it's corn. Yeah, you're not wrong, man. This is why James T. Kirk left Iowa. It's kind of funny. It's kind of fun. I'll give you that. It's kind of funny. It's kind of fun. It has the juice. Oh, God, now I'm doing it too. Damn it. No more. No more. Just subject change. What is that dish? What is this? What's this? You can't hit. Oh, gee. Oh, is it corn? gentlemen, I bring you more corn!
Yeah, I don't know, man. I mean, after last time...
This time shall be different!
Yeah, well, all right. Because I am hungry again.
It's not different at all! Is it, Steve? My childhood. More space news. This is coming from Peter Beck. Busy times for the recovery team. Components that have been to space and back are blasted through test and requalification. And he's showing a picture of a recovered electron. Ooh. Ooh. He'll be back. Yep. Only corn? Have you seen the linear city concept? The one that they want to build in Saudi Arabia. Yeah. Not a bad idea. But also, you know, it's got the juices. Stop that. Stop that. Stop that. Stop it. It's Epcot, and instead of circles, it's linear. Yeah. Lunar Starship airlock thing? What? What's this? Not a coinky dink. Alright. The surface lead of the HLS program office at Marshall show these slides of the Starship elevator. On the second slide, he says this is what the first steps back in the moon will look like. Fun fact, just the airlock section looks to be about the same volume as Blue and Dynetic's entire cabin. Not a coincidence, the Starship HLS airlocks are designed to be emergency cabins that the entire mission can be completed from if the main cabin is compromised. The astronauts could literally fly back to Orion with a tablet while sitting in the airlock. I don't know this person, so I don't... Oh. Huh. Interesting. The people that are following him... People that are following him, I'm inclined to believe that that's probably not bullcrap. Interesting. I think he got it from the same PDF those pictures came from. How could you extrapolate that from this? It's interesting that the airlock is... Actually, the airlock looks to be about the same size as a dragon. By lying. Easy. Okay. Next bit of news. PDF, not a single slide. Oh, yes. That makes a lot more sense. Anyway, let's go here. Massive, if factual. So this is coming from Harry Stranger. Gives us satellite pictures of 39A. Taken on August 28th, 2022. Some great progress on the Starship launch site. You can browse the full resolution image yourself here. I think I will. Would you like a quick tour? No. Alright, let's take a look-see. Why is it blurred out? Why is everything up? Hey, nice crane. Shouldn't have skipped the tutorial. You know what? You're probably right. Oh boy. Here, let's just look at this. Yeah. Reptilians. Crab people. PDF doesn't say anything about that. Okay. There's the Falcon 9 transporter erector. Hey, Signer, 31 months. Twitch canceled all my subs over the weekend. Thankfully, I remembered each and every one, including this one here. Sweet. Huh. Huh. Huh? As soon as I hit 8K populations in cities, I'm gonna have a hydro plant of epic proportions. Okay. Cool. Yeah. Actually, these updated pictures are pretty cool. For one, fellas, so, alright, let's take a look. Let's see what we can see. You have a bunch of concrete, rows right here. See those? That's the foundations for a fuel line. It's concrete, boy. Be excited about it. Now, see these? Those are generally used to carry fuel lines. Like if you look over here at NASA's originals, right? That's what those darker things are next to the pipe. It's fuel lines. Commodity transportation vessels, if we want to be very... I don't think anybody calls them that, but... Yeah, yep, you could start to see the fueling infrastructure going in there. And then you could see the posts where the orbital launch plate is going to go. Corncrete! Oh, God, don't do this to me, Newt. Mycon, you did it too! Why did you... No, it's not corn, okay? It is not. That is not corn. That is concrete. I don't know what that ring on the southeast side of the pad. It's a ring made of pipes with small pipes sticking out of it. Yeah. Oh, God. It's got the juice. Why, Chad? Why? I trusted you. Why? I trusted you. Why are you doing this? Why are you doing this? That was your first mistake. Oh, God. Oh, haircut. Yep. Yeah, I got rid of my hair. It was bothering me. It almost looks like a water system. I think that this thing's supposed to be a water tower. There's definitely methane tanks right there. And... See, I don't know. Maybe SpaceX is tapping into the old hydrogen tank to store methane. That could be a thing. Corn Tower confirmed. Corn X. I'm just gonna go on to the next news. Royal Caribbean. We've just announced our plan to implement SpaceX's Starlink to make us the first in the cruise industry to adopt the technology. This game-changing high-speed internet will be deployed on Royal Caribbean, Celebrity Cruise, and Silver Sea ships. Read. I'll tell you what, chat. It is in fact not corn. It's Starlink. It does not have the juices. Chat, I didn't want to do this. Didn't want to do this.
The salami lid ain't gonna fit, won't fit.
Didn't want to do this.
The salami lid won't fit. The salami lid ain't gonna fit like that. So the salami lid, and it's the salami salami lid ain't gon' fit. So the salami lid won't fit. Yeah. The salami lid ain't gon' fit. So the salami lid ain't gon' fit like that. The salami lid ain't gon' fit. So the salami lid won't fit. Yeah. The salami lid ain't gon' fit.
Stop.
So the salami lid ain't gon' fit like that. The salami lid ain't gon' fit.
Stuff I've ever heard.
So the salami lid won't fit. Yeah. The salami lid ain't gon' fit. So the salami lid ain't gon' fit like that. The salami lid ain't gon' fit. So the salami lid won't fit. Yeah. The salami lid ain't gon' fit. So the salami lid ain't gon' fit like that.
Link, please. What's this banger? The salami lid. It's salami. It's called Salami Lid Funky Hot Super Mega Music Remix Breakdown. That song is amazing. The salami lid. See, y'all been wasting time with corn. No, not. It's not corn. It's the salami lid. Okay. EJ's corn and salami review. God. I hate you so much right now. Great, now play it on an automaton. Oh, my automatones are inside. They're in the house. I gotta go get them. Genius stream idea. You. Don't do that. Do I look like I know what a JPEG is? I just want a picture of a gosh dang salami lid. Look what you found. I don't want. Okay. Just. Okay. Stop it. Stop it. Stop. What did I just walk into? You just walked into this! Dream Chaser do be almost looking done though. Tiles are on. Oh god, it looks like corn. Ah, damn it! I'm done. God damn it. Oh no. No. Corn pop? What? Cereal? It's a gosh dang corn. It looks like corn. Ah. Emotional damage. Turn it into an emote. Oh god. Dream corn chaser? No, that sounds dirty. Let's not call it that. They are celebrating the juices.
Discovery, go and throttle up.
No, just.
The salami lid ain't gon' fit, won't fit. So the salami lid won't fit. The salami lid ain't gon' fit like that. So the salami lid.
There you go. That's called Salami Lid in D major. I am Cornholio. Are you threatening me? Yeah. SMH my head. Why am I still here? I don't know. Probably because there's 2 Dream Chasers being made right now. I call this Solitude in E minor. Yeah, E minor, E minor, all right. Yes. Oh. There's another one, guys. There's another one. When will Dream Chaser be launched? Judging by the rate of completion right here, looking in this picture, G-Funky, we're still a little ways out. I'd say 3 or 4 months out, at least. But I can tell you this right now. They're starting to put tiles on it. It's got TPS on it. Tiles are like the last thing you put on that thing. It looks like a big shoe. Yeah. Yeah, low-key. Unfortunately, things that are designed to go like Mach 25 generally don't look like things that are designed to go Mach 2 or 3. Yeah, you need a much more blunt shape when you're going that fast, believe it or not. Yeah, stuff starts to look weird. I agree with you. There is one vehicle, though, that was designed to go Mach 25 that didn't look weird. You know what that is, dude? I call it God-tier engineering. The shuttle does not look weird. The shuttle looks amazing. No, floating. No. Buran? No. Buran looks like the Stig's American cousin, okay? It's all fat and weird looking. Didn't they retire them all? Yeah. They stopped using them and then gutted them for parts and then put them on Orange Rocket. 9'5", me boy, Cringe Bob. What's up, man? I thought Buran was skinnier. Actually, it's fatter. It's fatter and has bigger wing smirks. The Soviets when they went to make their own version of the space shuttle, realized that you can't put the wings that far back, because the reason why the space shuttle has the wings that far back is because the 3 main engines out back. You need to move your center of lift if you're carrying 3 Mack trucks worth of engine out the back, right? So Buran's wings are actually bigger, and they're shifted forward. Yeah. Oh, so now I'm known for being cringe. Hey, you posted that video on the internet, man. You post that video on the internet. Take it from somebody that posts a lot of themselves on the internet. It's pretty cringe, bro. It's a bit corny. Blue, I'm going to hit you right in the face. Just in. What's that? Is that coming from Mary? Possible static fire tomorrow. Okay. They got the overpressure notices for tomorrow, so we might see another Starship static fire. Sweet. Thanks, Vic. Bruh, damn. Why bigger? Did they slow down more in the upper atmosphere? They're not that much bigger, Aqualex. They're slightly bigger. I have no idea why. Maybe more down mass capability? Bruh, damn. Third time is the charm. Oh, Thomas and T-Man posted that. Cool. Sweet. The next Artemis try is on Friday, Stribbin. It's actually, they moved it to Saturday. Saturday is also an opportune launch window, but weather could be an issue. Now I have to change my flight so I can be there for the next SLS attempt. 95... Wait, why are we linking Princess EJ? Oh, damn it. You know, after a while, static fires just don't have the excitement they used to. Yeah. Given the air, the Russians probably wanted to slightly one up the U.S. Yeah, Dave, that's my thinking. The other thing could be that they needed to make Buran heavier to compensate for the fact that it didn't have main engines in the back. You think SLS will launch Saturday? If I recall correctly, Buran had jet engines for cross-range flight. Maybe that's why the wings were bigger. It could have them, Uncle Bill. Yeah, it had the thing for it. Only the flight test article had that. The atmospheric flight test article. They were glued on, floating. Yeah. Do I think SLS is going to go? It's contingent on a couple of things. If there's a bad sensor, then maybe. Maybe. NASA has to keep working through its progress flow. I have to get an update from NASA before I can really tell you conclusively. I'll tell you that Saturday is next attempt, and that's about it. It really depends. It depends on a lot of different things, guys. The gist of it is that NASA changed their fueling procedure and from the green run, and changing the fueling procedure from the green run. Damn it, you stupid bug. There's a skeeter flying around. Gotta get him. No, didn't get him. They changed the fueling procedures from the green run, and yeah, the different fueling procedure could have potentially caused engine 3 to not bleed correctly, but it also could be a bad sensor at the same time. I don't know. NASA has to go comb through the data. And either way, they're going to try one fix or another. Basically, long story short, they have a problem with hydrogen leaks on the system. And don't get me wrong, like, these problems it's not like a problem like, oh my gosh, we can't be able to fix it. It's the first time they've used this thing. It's the first time they used the launch vehicle. It's going to take some time to get the bugs ironed out, that's all. Think of it as a beta test. You're going to you encounter bugs during a beta test. That's not a problem with your game, right? It's just stuff that needs to be fixed. Stuff that needs to be ironed out, that's all. Would a sensor problem cause a rollback? Depends. They might send it. They could. If it's a DFI sensor that's malfunctioning 95, they might, if they think the risk is tolerable and an acceptable risk for launching, they might just say do it. If it's a bad sensor, I think they still go because it's a DFI sensor. Yeah, Hibbit. Mm-hmm. So, most DFI sensors are not a constraint for launch. Bingo, Rev. Yeah. If the developmental sensor is giving us problems, and they can conclude that the DFI is bad, I would send it. Just send it. Ultimately, like you said, scrubs get forgotten, ruds are forever. Bingo. They got 3 other engines to get data from. If the DFI sensor is malfunctioning, Aqualex, a DFI sensor on the bleed system is malfunctioning, and they know for sure that that engine is down to temperature, who cares? DFI is a developmental sensor, dudes. It's developmental, meaning it's only there for that launch. If the thing that's only there for that launch on the first SLS core stage test article, for the most part, is malfunctioning, just send it, because the next one won't have it. That's why I said they're probably just going to let it go. Like, they'll probably fly. If they can conclude that it's a bad DFI sensor. If it's not a bad DFI sensor, that means their fueling procedure is wrong. And here's the thing. I don't necessarily think that that's going to constitute a rollback or anything. Procedural stuff has nothing to do with the hardware. They are, however, going to go and retorque the bolts down on the tail surface mass carrier umbilical plate and the bolts on the catch can system, because they know from the wet dress rehearsal that they can become detorqued. So they're going to go retorque those bolts. And yeah. Now that I'm thinking about it, there is a high probability that it will launch. Now that I'm that's just my gut though. Wait for NASA. Wait for NASA. I guarantee that if information was as quickly disseminated in the 60s as it is now, there'd be similar FUD about Apollo. It only looks bad to us because we're exposed to more of the details. I don't think there's necessarily anything bad at all here, Dish. I don't think there's anything bad at all. It's just teething problems for a new launch vehicle. In fact, anybody that says it's bad, I want to kind of hit in the face, because they're being slightly dishonest. What's that really bassy sound? It's the fan. It's the fan. I have to fan. Can someone decrypt the DFI? Developmental Flight Instrumentation, meaning it's only there for the test flight. It's a developmental thing. It's a test flight sensor. Guys, there's OFI and then there's DFI. Okay, operational flight operational flight instrumentation and developmental flight instrumentation. Okay, every time you launch it, every time that NASA launches a new vehicle, the vehicle is outfitted with a ton of extra sensors. Why? Because you want all that data. You want the data. You want more sensors than what you would normally run because you want to get good instrumentation and a good baseline data set for your vehicle. They did it with Saturn V. The shuttle had a freaking smart car sized developmental hard drive in the payload bay during the first mission to take all the data, to get all the data from all of the sensors on Columbia. Yeah, the thing was huge. The DFIU, the Developmental Flight Instrumentation Unit. You guys have seen it if you've ever looked up pictures of STS-1. It's those two big squares that are sitting inside of the payload bay. Here. Right here. There it is. See? Look at all the sensors. That's the DFIU. SLS has all that extra wiring on it because it has DFIU. It has a bunch of developmental flight instrumentation sensors on it, not DFIU. DFIU is from the shuttle. So, if they conclude that the developmental sensor is junk and the operational sensor is working, then send it. Who cares? You ain't getting. It's not like you're reusing it. Do you have a noise gate? No, Forlorn. I'm not. Guys, I don't want to talk about the audio. I know the audio is distracting. I get it. It's because I don't have the full acoustic setup inside of this room just yet. It will change in the future. I don't need a solution. Could the DFIU survive a shuttle loss? I don't think so, Aqualex. Did they miniaturize the DFIU eventually? No, they took it out. It's more you hitting the desk that's causing the booming sounds. Okay. Anyway. 2 Dream Chasers being built, which is pretty sweet. I think that's all the space news that I got. There are some other things, but I'm good for now. There is an insane backlog of Starship stuff. Yeah, there's an insane backlog of Starship stuff right now, but we'll probably pick a day and go through all that. Would you trade the shuttle and the ISS in 20 years of continuous on-orbit habitation for a continuation of the Saturn V? Yes. Yeah, Ark, absolutely. Of course. You know what the messed up part is? Probably be cheaper. Yeah. Thought so. Same. Yeah, you know, you don't get full reusability, and that sucks. But you could work on it. You could work on trying to find ways to make Saturn more reusable or cut costs. Imagine a Saturn V with like a friction stir welded aluminum iso grid.
Discovery.
Think about the S1C. The S1C had an intertank design. It had separated tanks because of structural load, because the welding methods of the time wouldn't be able to handle 7.5 million pounds of thrust pushing up on it. An aluminum friction stir welded iso grid could. Oh yeah, easily. We know because we were just talking about one that's going to launch. Remember that part? So, could have probably built an ISS with a Saturn 1B and Saturn V. That's what I'm getting at, Rev. We could have probably built something like Mir, but with Skylab modules. and then frankly a bigger ISS, also capability of going to the moon pretty much whenever we wanted to, and probably do that for cheaper. We could use Skylab modules to work and Saturn 1B to work on low Earth orbit operations, while also going out to the moon. And I'll be 100% real with you, that probably would have been cheaper than the shuttle program. Yeah, it probably would have been way cheaper. I think an incrementally upgraded 1B could have been pretty capable. The Saturn 1B was a great vehicle. Great vehicle. Imagine if X-15 derived vehicles developed further in the interim. I mean, yeah, I'm not really a fan of strato-launching stuff, Aqualex, because you need a bigger plane, the bigger the thing you want to get into space. Saturn V and Saturn 1B would have been just fine. We would have been able to keep going with it, and then Saturn 1B could have had all kinds of upgrades, even to the point where maybe you could land Saturn 1B's Falcon 9 style. Can you imagine an uprated Saturn 1B with RS-27s in the first stage instead of H1s? That was the motor that came after the H1. That's the next motor in the tree, the Delta II engine. Putting that at the bottom of a Saturn 1B with a two-tank system instead of a bunch of tanks wrapped around each other with an S4B-200 on top of that would be a damn good capable launch vehicle. And then, on top of that, if you put Titan SRBs on the side of that in 4X configuration, which you absolutely could do, in fact, they were thinking about doing it, you have something that's more capable than Delta IV Heavy, more capable than Vulcan VC6, more capable than Atlas Heavy, more capable than Titan IV, way more capable. Yeah, but why spend money on developing something more, Aqualex, if you already have the Saturn V and the Saturn 1B? That doesn't make any sense. And then, of course, the cost to produce Saturn V engines would have gone down over time. They would eventually have adopted stir welding, which came around in the 80s, not that far off from the Apollo program. Stir welding the Saturn V components would have brought costs down even more. Milled aluminum isogrid could have been a good incremental upgrade. Carbon fiber fairing for the Saturn V would have been better. Carbon fiber fairings for Saturn 1B would have afforded you a 6-meter fairing out of the box with a vehicle that could put 25 metric tons into space. Oh yeah, that would have been excellent. Yeah, I would take that over the space shuttle. Ark, I love the space shuttle. It's god tier engineering. I love it because it exists. If you could go back to December of was it December of 72? I think it was like September of 72 or something like that, when Apollo 16 was up there. If I could go back to that point and say, space shuttle or the space shuttle or Saturn V, I would have kept the Saturn V all day. Even with the potential promises of the space shuttle. Even if the space shuttle worked as advertised, I still would have kept the Saturn V. Forlorn, I love the space shuttle. You know that. I just don't think trading super heavy lift capability was a good idea. That was stupid. We still haven't recovered from that. Could we have built the ISS without the shuttle? I'm not sure, Goat Prince. But see, with the Saturn V, when you can put 120 metric tons into space, you could work. The point is that you could work on making reusable vehicles that were based off of the Saturn V instead of clean sheeting the design like they did. You could have made Dream Chaser, something like Dream Chaser, and put that on a Saturn 1B. It would have worked just fine. In fact, that's what Max Vazet wanted to do. That's what NASA wanted to do. Work on reusable human-rated spacecraft first. They wanted to do something more like Dragon. And they said, no, go full reuse. Which, once again, I don't have a problem with that. I like the space shuttle. But if given the choice, I would keep the Saturn V. The thought was about where we could have gotten if we didn't need to push space planes to the forefront as a replacement. Yeah. Oh, jeez, Dish. Okay. I mean, There was a plan to convert a second stage to a lunar orbit station. John, the Apollo applications program, reading about it just kills me. It's so well thought out. Here. They basically wanted to take the upper stage, and so think of Saturn V with the LEM and the CSM on top of it. Where the LEM is, they would have taken that out, and they would have put an airlock like they did with Skylab. In fact, Skylab was a prototype for that. And they would have done something like this. It basically would have been a space station module attached to the top of an S4B. And the S4B would have put it on the transfer burn to Venus, and then after that, there's an airlock bulkhead going into the S4B, and it would have been evac'd and used as living space, as a habitable space. That coupled with the airlock. And they basically would have flown with the airlock, with the Apollo capsule docked to this S4B airlock space station module with a wet workshop into it, and that would have became the spacecraft. And then, you fly by Venus, and then when you get back, you separate the capsule and the service module, and this whole thing burns up, and that whole thing burns up. That's what Skylab was a test for, guys. That's what it was trying to do. Apollo was going to go places. You could use these to get out to the moon. Once NASA... From there, NASA wanted to work on reusable lunar landers. They weren't going to be reusable right out of the box. What they basically wanted to do from there is send out unmanned Saturn Vs with the LEM and no service module. So it would have ended up looking something like Skylab, like a cargo Saturn V, right? And with just a descent module and an insane amount of payload weight, or payload mass down to the moon. Basically, HAB modules down to the moon. They wanted to use one-time use LEMs, land HAB modules on the moon, and then send a regular lunar module and land that, and then you would be afforded extended durations down on the surface. Basically, effectively building a lunar base. That's what they wanted to do. I would trade that for the shuttle, yes. Also, yeah, that's the other thing. Eventually, the Saturn V was working on nuclear-powered third stages, which were capable of making up to 900-second specific impulse in vacuum. Effectively making a reusable tug between the Earth and the Moon. What's that, Zay? That's actually kind of funny. What is this? Is that an Ares 1 on a milk stool, but not on a milk stool? Is that cool or not? I can't tell. But yeah, Ark, that's my thoughts on it. I love the space shuttle. I love it. I love that it existed. It's an amazing piece of kit. The only problem that the shuttle program is guilty of is not flying more. Yeah. The idea was to have Ares 5 and Ares 1 both use the same pad. Oh. Couldn't they bring back some of the proposals from the Apollo applications program and utilize SLS? I would love for them to do that, Goat Prince. In fact, with SLS Block 1B, you absolutely could. Sure. The exploration upper stage. SLS is the Block 1B upper stage is going to... Block 1B upper stage is basically going to have an adapter piece right here called the Universal Stage Adapter with the Orion Stage Adapter right here. You could literally do the same thing with this and send people on Mars flybys. You could basically put a gigantic HAB module in here with solar panels and fuel cells, and then use the hydrogen tank as a wet workshop, and then the LOX tank as a waste tank. And 4 RL10s would afford you an insane Delta V. You could do Mars flybys with this. Sure, why not? You'd have to dump the Orion Stage Adapter, the OSA, but it's doable. Yeah, that's the stage. This is what SLS should have on it right now, but that's another story. The idea... So, Zay, you said your idea was to have Ares 1 and Ares 5 use the same pad. So why didn't you just do... why didn't you just do this? Instead of a milk stool, because they both use the same SRBs, why didn't you just use one of the SRB hold down points? And then make make the access arms on the left side of the ML instead of... and the SLS ones or Ares 5 on the right. No, Dunpeel, not yet. It's scrubbed. They found problems with the hydrogen systems. They're fixing it right now. It would have been great if they could live up to the planned launch volume and easy refurbishment. Jim, the only way they were going to do that is by flying it more, not less. Well, because Milk's still funny and Saturn 1B go burr. I have no good reason. Okay. Cool, just making sure. But yeah, the Apollo Applications Program had some insane ideas. These are really cool. Okay. We have a Starlink launch a little bit later tonight, dudes. It's a good ways away. Have you all talked about the Tube Starship rumors going around? Tube Starship rumors. Ordinary Ace, I'm trying to design a reusable SSTO in Kerbal. Why was the shuttle's payload integrated vertically instead of horizontally? It's not that it was integrated vertically instead of horizontally, Ace. It's that it could do either one. The shuttle could have horizontally integrated payload inside of the orbiter processing facility. The rotating service structure was there so it could do both of those things. Yep. When is the next attempt for the moon? Dunpeel, it's Saturday. Saturday at 2 my time, so for you it's probably like 7, 8 o'clock. Got it, thanks. No problem, Ace. Supposedly SpaceX might push reuse back on Starship and go expendable for the first launches. I've heard that too, MotoKid, but I have no way to prove it. I did see that a nose cone inside of one of the tents at Boca Chica was different, i.e. it had no tiles on it in the manufacturing tents, but that could have just been a different coating. But yeah, I have heard that, dude. 2 p.m. or a.m.? A.m. Do you know if this launch is flying northeast? I'm just outside of Pittsburgh. I've been trying to see the second stage. Trainman, the Starlink launch? No. No. It's launching from Vandenberg. Polar Starships. Yeah, the Starlink mission tonight is going out of Vandenberg. In terms of Artemis 1, I'm not 100% sure what the launch azimuth is. Yeah, it might be a little too far.